virtual global virtual seminar series on exciting advances in manufacturing automation. As per the schedule, our sessions will start by 10 o'clock. Meanwhile, to show you the various activities of the GITAM, I am playing these particular videos, one or two videos, only to provide the better awareness towards the GITAM and how the GITAM is involved in various activities. To show the glimpses of that, I am sharing this video.
Welcome to GITAM, the award of academic excellence.
GITAM recognizes the relevance of Mahatma to all disciplines, ranging from medicine and law on the one hand to philosophy, architecture, and other humanitarian disciplines.
With an expert and dedicated faculty, great infrastructure, a vibrant campus, and a plethora of core and elective papers, this institute proves to be the best.
It is great honor for me to receive the prestigious GITAM Foundation Award.
చెప్పండి
ఎక్కువ ఎక్కడ రావట్లేదు కదా
అవుట్లెట్
GITAM యూనివర్సిటీ ఉన్న కాలేజెస్ ఎన్నో నాకు ఉన్నది ఎన్నో ఉన్నాయి వాటన్నిటిలో కొద్ది కాలంలో #1 ప్రైవేట్ యూనివర్సిటీగా వెలిగింది అంటే
I was coming into the university and I was really impressed with the infrastructure. Fabulous infrastructure.
All the 3 campuses are well equipped and the best in their academic pursuit.
Please have a look at my campus, Vizag campus. సురేష్ సురేష్
సార్ చెప్పండి.
ఓకే కదా?
ఓకే సార్, ఓకే.
ఛానల్ గ్యాదర్ అయ్యే వరకు అలా ఉంది సార్. 10 o'clock వరకు ఒక 100 మంది వస్తే స్టార్ట్ చేద్దాం. లేట్గా జాయిన్
వచ్చేస్తారు 10 కల్లా వచ్చేస్తారు.
Hello, good morning, Professor Turan from Malaysia, University Malaysia. Good morning, sir.
Morning.
Welcome to GITAM, sir.
Yeah, thank you.
Sir, we'll start as per the time, sir.
Okay.
Okay, thank you very much, sir. Thank you. Suresh?
Sir.
Dr. Suresh, can you make a call to Sandeep, Dr. Sandeep?
Okay,
so
sir,
that he
okay.
will join.
Okay, sir, I'll make.
Good morning, Dr. Shobha, madam. Sir, good morning, sir. Narendra.
Good morning. Good morning.
Sir.
Morning, sir.
Good morning.
Good morning.
Sir, Professor Narendra, I want to introduce Mr. Dr. Fayaz Muhammad Turan from Malaysia, sir. Dr. Turan, sir, is Dr. Narendra is one of the senior professors in the department, sir.
Hello, Dr. Narendra. Hello, Prof.
Sir, Narendra garu mimmalni palakaristunaru.
Hello, sir. Good morning, sir.
Morning.
I am good morning, sir. Yeah.
Suresh, can we start? As we have reached the 3 digit. Sir, Narendra garu, with your permission, I would like to share details about our department as for the benefit of the external experts, sir.
Okay. Okay.
Sir, Dr. Turan, sir, we would like to present a few details about our Department of Mechanical Engineering, GITAM University.
Okay.
Have a glimpses of that, sir. Dr. Banpavan.
Yes, sir. Good morning, sir.
Is the screen, everything is okay?
Yes, sir. Everything is okay, sir.
Dr. Turan, sir. So we belong to the Department of Mechanical Engineering, GITAM University, Visakhapatnam, which is located at the edge of the Bay of Bengal. Welcome to the 2-day virtual seminar series, which is organized by the GITAM University on exciting advances in manufacturing automation 2020. On behalf of organizing committee and GITAM University, my sincere thanks to you, sir, for accepting our invitation to be part of this, for delivering an expert lecture on decision-making methods. Thank you very much, sir.
You're welcome.
Yes. This is our vision, sir, to become a global leader in mechanical engineering education that caters to their ever-changing industrial and social needs with innovative solutions. This is our vision, and we have a common mission throughout the university, sir. So our Department of Mechanical Engineering was established along with the GITAM, and the Department of Mechanical Engineering is one of the oldest department in the GITAM University. GITAM University is a 40 years old university. Initially, it was started with the College of Engineering. Later, it was transformed into the university, deemed to be university. And we were sanctioned autonomy in 2003, and we were accredited by NBA. And every year, we will try to conduct some endowment lectures in the name of most popular President of India, APJ Abdul Kalam. And one of the endowment lectures is constituted on the name of popular scientist in India in the defense sector, Dr. B. Bhujangarao garu. And we were, our institute, particularly our department is, along with the civil engineering department, was recognized one of the research institutes. We were sanctioned with some funding also from the government of India. This is the outlines of the various programs which are offered from the Department of Mechanical Engineering. Now, we consist of total 42 faculty members, out of which 24 members are having PhDs, and one person is having the postdoctoral fellowship from USA, and 15 members are pursuing PhD. Out of 42 faculty, 10 members are with industrial background. And our department faculty, 8 members were awarded with Young Scientist Award. It means Government of India is giving some amount to progress their research further. This is the distribution of our experience and specialization of the various faculty members in the mechanical engineering department. And these are our department is focusing mainly on not only mainly these are the I mean I have placed this particular slide is most of the publications are coming from this particular area. Even though there are many number of publications are coming, the majority of the publications are coming in this particular area. So this is about the data with respect to the December 2019 before COVID. These are the popular publications of one of our faculty members. In which if you consider the planar and production, that today's impact factor is around above 7 I think, 7.3 something. Now, some faculty members are also involved in publishing the books and book chapters. This is the total worth of the projects which are sanctioned to the faculty of the mechanical engineering from various organizations of India. These are the projects which are sanctioned by Government of India to the various faculties of the mechanical engineering department. I have included completed projects also. This is about the completed projects and various equipment which are procured under the funds of government agencies. We have equipment. What are the equipment which is mentioned in the curriculum syllabus? Our university supports for that equipment. We have that particular equipment, but I have intentionally placed this particular slide showing that these are the equipment which are procured under the funds of the external agencies like government agencies, from the funds of the government agencies. So the students who admitted for various programs in the Department of Mechanical Engineering, they will have enough scope to explore the research interest. These particular machines or equipment, they are not in the curriculum, but these are the machines are part of the research projects. So whoever admits in this particular stream, it can be PhD or MTech or BTech, they are allowed to work on this particular machine. The principal investigators of our department will actively make students to involve in these particular projects and equipment. And this is one of the equipment which is procured by the GITAM University, particularly from the with the representation from our department, mechanical department, a fatigue testing machine, instant fatigue testing machine. The cost of the machine is nearly almost 1 crore. This is about involvement from our department in the consultancy. And this is about the patents, which for some of my faculty members have already submitted. They are in an active stage of awarding the patents. These are the brief outlines about my department credentials. We have actively conducting the workshops, training programs. We'll invite experts from other countries like you, sir. This year, this academic year, we have started with a faculty from University of Malaysia. Very happy to be you make us very much happy, sir. Thank you. And this is about the endowment lectures. Our department has already organized at various stages. They are the popular personalities like Professor Samir Iqbal from University of Texas, Professor from New Zealand, USA. Professor S.S. Rao is a popular person because you part of this particular industrial engineering area. Definitely you might have come across this particular name, Professor S.S. Rao from University of Miami. This is about the collaborations of our university is having. Hindustan Petroleum Corporation Limited, Bangalore, and Steel Plant, Visakhapatnam Steel Plant, Rashtriya Ispat Nigam Limited, and CITD. It is one of the popular institute in India. Like that, we have many collaborations. This is the infrastructure facilities available in the department, and this is about the students' progression. So academic monitoring, ICT enabled learning. We are very much focusing about the slow learners. Everything is as per that. This is about the co-curricular activities of the Department of Mechanical Engineering. Is of HOD Professor MRS Satyanarayana. This is extracurricular activities. I think everybody is aware of that India was affected by Hudud, particularly in this part of location. We were affected by the Hudud cyclone, where our faculty and students are involved in assisting the people. They are the prominent alumni from the Department of Mechanical. And all the activities which really comes under this particular thing, sir. The Department of Mechanical Engineering has developed a forum which promotes the research activities. So far, we used to concentrate inside the institute and inside India. With your presence, it became global, sir. So that is why we named it as Global Virtual Seminar Series. Thanks, Dr. Turan. Thank you. Now, I would like to request Professor Narayana to introduce our external guest, Dr. Fayaz bin Muhammad Turan from University of Malaysia.
Good morning to all of you. It is my privilege to introduce our guest, Dr. Fayaz bin Muhammad Turan, to the audience. At present, he is working as an associate professor and a dean, Faculty of Manufacturing and Mechatronics Engineering Technology, University of Malaysia, Pahang, Malaysia. His field of expertise, engineering design, manufacturing systems, and sustainability. His first experience, he worked as a jigs and fixture design engineer during 97-98 in Sanko Seiki Manufacturing Co. Limited, Japan. And during 98 to 2004, he has worked as a manufacturing senior engineer in Sanko Precision in Selangor, Malaysia. And during 2004 to 2013, he worked as a design engineer in ALPS Electric Malaysia, Pahang. He has published more than 67 publications with impact factor in international journals. His professional achievements, he is the registered professional engineer with practicing certificate of Board of Engineers Malaysia. He is the corporate member of the Institute of Engineers Malaysia. He is a registered practitioner technologist with the Malaysia Board of Technologists. He is a chartered engineer of Engineering Council UK. He is the corporate member of Institute of Mechanical Engineers UK, and he has Malaysia Skills Certification Level 5 Industrial Product Design Management. On behalf of GITAM University, we welcome you, sir. We are waiting for your valuable lecture, sir. Over to the BSP.
Yes, thank you, Professor Narayana Garu. Thank you for your very good introduction. Now I would like to request Dr. Fayaz bin Muhammad Turan to take the session. Yes, sir. Is that okay, sir?
Okay. Thank you very much to Dr. Prasad and GITAM University for inviting me to to give a lecture today. So I think I don't need to introduce myself since Prof already introduced me just now. So I'm now a Dean of Faculty of Manufacturing and Mechatronic Engineering Technology. My focus area basically is in the design. Okay, so let me introduce about my university. Can you see my slides?
Yes, sir. Yes, sir. Please go
okay?
ahead, sir. Very much fine.
All right. Okay. All right. So University Malaysia Pahang, or in short form, we call it as a UMP, is one of the 4 technical university in Malaysia. So it is it was established in 2002. It's still new. We are just 18 years old. Okay, and our focus basically is more on the wide range of skill-based higher education programs. Okay, on top of that, we also have research and also promote the commercialization and so on. We are recognized as a 5-star world-class technological university, and the university basically receive a lot of awards nationally and also internationally. We are recognized as a 5-star in teaching, employability, internationalization, facilities, innovation, and inclusiveness. And in terms of ranking, so UMP basically is a top 2.6% in the world, and also top 1.8% in Asia. And last year, we are ranked at 134 in Asia. For the top 50 years, under 50 years old university, we are at the 101 to 150 in the world. And in terms of graduate employability, we are ranked in 301 to 500 in QS employability ranking. We have actually 4 colleges here, namely as College of Engineering, and secondly we have the College of Engineering and Technology. So the difference between these two is College of Engineering is focused more on the theoretical, which is more on the theory, and for College of Engineering and Technology we focus more on the applied engineering. And we have also College of Computing and Applied Sciences, and we have another one is College of Management and Humanity. And my faculty belong under the College of Engineering Technology. So we have 4 academic colleges and 16 departments, faculties, and centers. We have a wide range of, we offer a wide range of programs. We have 6 full-time diploma programs, 37 full-time bachelor degree programs. We have 12 master degree program by coursework, and also we have also a master by research and also PhD by research. As of 2019, we have about 12,600 students, whereby about 90% above, about 11,178 is undergraduate, and 1,425 is the postgraduate students. And in terms of international students, we have about 743 international students, and out of this, 49% is PhD students, 32% master, and 90% degree, bachelor degree students. If you look at the background of this international student, most of them coming from Yemen, Iran, China, Indonesia, and we have 31 from India, okay, and the rest from several countries in the world. And as of today, we have about 22,340 alumni, and out of these numbers, we have about 425 international alumni. Okay, I think that's all for introduction of my university. So now I want to go to the the main topic to be delivered today. I would like to actually share my recent findings in my research on with the title of Reliability Information to Support Decision Making for Product Development. So the overview of my presentation today will be, I will start with the introduction or background, which I will explain about the aspect of product development engineering. Then the current problem associated with the product development engineering areas, the objective of my research, and I would like to also to highlight about the methodology of my research, and the application, result, and the conclusions. When we talk about product development engineering, it is actually related to the early stage of product development, which is the design stage. If we look at in terms of cost, the design stage contribute the highest, I would say the highest cost throughout the product development process. So if you look at the area of design, most of the researchers actually attempt to, to introduce the best techniques on how to reduce or how to simplify the design process so that we can reduce the cost of design. As I show in my slide here, so if you look at here, the growing emphasis for the enhancements of product development engineering to support new products. Basically, there's a lot of techniques has been introduced by the researchers to, as I said just now, to reduce the product development time. And from this figure that I show you in this slide, when we talk about product development engineering, it covers a wide range of area. Like, we covers the design and development stage. We also covers the reliability area, the quality, the serviceability, manufacturing, testing, and assembling of new products, and also ideation. Okay, and I can see that the product development engineering basically covers the complete process of bringing a new product to the market. There's one researcher from Taiwan, which is Lee. So he has actually highlighted that one of the critical area in product development engineering is the reliability. Even though most of the researchers focus more on the product conceptualization, but only some researchers actually focus on the reliability, and he's actually attempted to to focus on reliability, and introduce several techniques actually to help the designers actually to integrate or to include the reliability information into the design process or design stage. Because at the end of it, the purpose of this technique basically is to to make the product attractive and can be accepted by the users. So these are actually and this figure it shows that the aspect of product development. So it means that in this research, I would like to focus on the reliability. As I said just now, most of the researchers previously, they are actually separate between the reliability and also the concept, design concept. So as I mentioned here, I divided into two. So the first part, I'll talk about the reliability, and the second one is the concept assessment. If you look at most of the researchers, they try to separate these two things because of when you combine these two, your process will be too complex. It will take too much time to actually to integrate both techniques, and they require certain approach or certain techniques that can actually integrate these two areas. So some of researchers they focus more on the understanding of the reliability concern in the complex product. Okay, for example, in 2015, he focused more on the failure causes of the reliability model. I mean the reliability area. And Zubair and Bajri also focus more on the predictability. in the reliability area. Same goes to Liu and Anderson in 2015. Focus more on the better management, opportunity for better management. They also in 2014, Berlin identified the reliability problem areas. So all of this basically interrelated. And finally, these researchers actually attempt to improve the product design and development in the context of reliability. Okay. And their findings or their contribution is basically giving the designers the opportunity to focus on the area of greatest reliability needs during the early stage of product design. And on the other hand, when we talk about concept assessment, there are some researchers basically focused to understand the complexity of the design by assessing the concept. By assessing the technique of design concept. So if you look at this, Zai in 2009, also myself in 2013, basically we developing a mathematical model to help the designers to assess to optimize the process or the conceptual design process. So the idea of this techniques is basically to improve the decision. Okay, the decision in the product development engineering. Since in the conceptual design process, it is a complex process. We deal with a lot of variables, a lot of numbers, and also the reliability. Also, we deal with a lot of, but in the approach is basically different, but with the same aims, which is to reduce the product development time and also cost. So current problem is associated with the product development engineering area. If you look at the current product development engineering area, it is difficult to effectively evaluate the large number of solutions, since there's a lot of solution, various solutions with a different approach, different techniques. It's very difficult for us to effectively select the best solution in the particular area of design process. There are also some reliability issues at the early stage of product development process, and it will affect the decision making process, since we don't have the effective we don't have the effective solution, so that it's very difficult for us to make a decision. Okay, and some of it is very difficult to consolidate the sources of relative information at the early stage product, since the information is very limited at the early stage of product design. So it's very difficult for us to get the reliability information. At the same time, it's very difficult for us to get the best solution. Okay, and with this constraint, so it is actually representing the incomplete and imprecise information that will give a tough situation to the designers to make a final decision. Even though some effort has been made by some researchers in improving the techniques of decision making models, but there's a need actually for a method to adequately and effectively address the product reliability and design concept. So which means that in this research, I'll try to combine both the design concept, and also the product reliability. Instead of we conduct it separately, in this research, I'm trying to combine these two to become one framework, so that it can help the designers to actually reduce the product development time and also the cost. And if we look at this, there's some researcher. There's one researcher, Xiao, in 2016. he highlighted about the accounting for the decision maker subject adjustment. So yeah, of course, if we deal with the human perception, it's very difficult for us actually to quantify. Yeah, and he's focused on this. And they express Lee in 2008, so expressing the information in the several dimension and to reflect the assessment information in a more holistic manner. As I said, since the feedback from the, for example, from the respondent, sometimes vague, it's very vague. So sometimes the designer need to have, need to have a certain techniques actually to quantify. And then this quantification data should representing the actual, perception. It's very difficult for us actually to get the exact value actually for designer to use it as a reference for them to decide the product specification. And then one more thing is we normally, I mean, most of designer or most of the researcher normally focus on the technique on how to help designer, but they don't actually some of them, I mean, not many researchers actually focus on the how to deal with the attitudinal character of the designer. So in this research, I'm trying to actually include the factor of the attitudinal character of the designer to be one of the parameters to be considered when developing the model of decision-making techniques. And of course, finally, I want to make sure that the techniques actually is flexible enough and adjustable, so that and generic, so that the model can be used not only in the design, it also can be used in other areas. Okay, so these are some of the information that I get from the literature. So that from this gap, I'm trying to first is define the reliability assessment method using elicited expert opinion for detecting the root cause of failure in the existing product. So that I want to develop one assessment techniques that can help the designers to get the exact data or to detect the root cause of failure in the existing process. And from the objective one, okay, I'll move to the objective where I want to develop a novel and flexible. As I said just now, when we're developing a model, it should be flexible enough and adjustable enough so that it can be, it can be used not only by the designer in certain area, it can be used also in the other area. Okay, so that this flexible and adjustable methodology can effectively support the designer in making a high-level decision making. Okay, and also I want to apply the newly defined and developed reliability in the product design assessment. As I said just now, the basic concept of my framework is I want to combine both the reliability and also the concept, the design concept. And finally, the final objective is to investigate the application of the define and develop method in the real life case study. So I will actually apply, validate this method in the real life case study. So the new reliability assessment model. So basically for this one, I based on the traditional fuzzy TOPSIS model. The most common decision-making tactics, which is the TOPSIS model. So however, based on this TOPSIS model, I extending it by implementing or by integrating with the intuitionistic fuzzy environment. Okay, and then as I said just now, since I don't consider the attitudinal character of the designer, so I introduce the attitudinal parameter. Then, of course, it is not just simple things to combine the quantitative and the qualitative, data or qualitative method. So that's why I need to integrate using the technique of exponential related function. Okay, and when we deal with the human perception or human judgment, so we need to have the aggregation technique. So in this case, I use the intuitionistic fuzzy weighted averaging operator, IFWA. And step number 5, so I will use also the exponential related function based separation measures. And finally, for the computation or calculation, the final calculation, so I use the intuitionistic fuzzy entropy, okay, to calculate the criteria weight. So these are the detail of the algorithm of the model. Basically, I divide it into 6 steps. Okay, whereby the step number 1, I'm trying to actually to aggregate the evaluation of the decision maker using the intuitionistic fuzzy weighted average, okay, IFW operator. So the metric shows here, I mean the first metric that I show here, okay, here, it's basically the generic metrics. So I just interpret, okay, the general variables, I mean the general metrics. So I just interpret in the context of my research. Okay, and for step number 2, so the matrix number 2 here, and then in this case, okay, I'm used the exponential related function. This is where actually we include the we try to quantify we try to quantify the human perception into a numbers. Okay, and this the step number 2 actually it is the the better performance rating from the previous metrics. Okay, the previous metric is general, and then I integrate with the exponential function to become the customized metrics. Okay, and then the step number 3, we will have the intuitionistic the ideal solution for the positive and negative. And finally, step number 4, the computation to get the using the weight of the criteria. And the step number 5, we get the closeness coefficient. Okay, and based on the closeness coefficient value, we will rank the alternative. So this is the first step. The algorithm of the first step include the the reliability to get the reliability information, right? And of course, the rank of alternative will be in descending order. The highest number will have the high priority. We try to actually evaluate the algorithm by using the data from the previous researcher. Okay, we based on the U in 2011, which is he attempt to get to implement the failure detection problem. So we use the same data by U. He focused on the severity, occurrence, and detection. Okay, using the conventional fuzzy topsis. Okay, and he finally get the ranking here for 3 attributes: A1, A2, and A3. Right, and from his research, it shows that A2 is the highest priority, the highest ranking. The second ranking is A1, and the third ranking is A3. And by using our proposed approach, we try to get the same number basically, and then we compare with the U results. It shows that the A2 also get the I mean the highest ranking. So it means that at this stage, so our proposed approach is actually give the same result as what had been done by you in 2011. And we move further by considering the closeness coefficient of the failure modes. Okay, now we use the different data from E 2010, but we use the same matrix. Okay, after we compute, okay, using the same techniques, we get the ranking like this. So in this case, we have 4 attributes, and the second attribute A2 shows the highest ranking, followed by A4, A3, and A1. If we compare to the another researchers in 2014, Liu and Ren here, okay, this is a Yi. So both of the researchers using the same traditional, I mean the conventional fuzzy topsis, but Liu and Ren, they integrate with another approach, I mean with another techniques, and we try to compare these two with our proposed approach, and it shows that the result, I mean the ranking is same as, I mean, what has been done by Liu and Ren and also Yi. Okay, so at this stage, we believe that, you know, our algorithm, our model actually can be accepted, since it gives a same result, okay, as Liu and Ren also Yi. Now, this is another challenge. Just now, I mean, the metrics that I showed you just now, we are not considering the attitudinal parameters or attitudinal character of the designers. Okay, if based on the attitudinal theories, there are 3 main criteria of attitude, or 3 main elements of attitude, which is number 1 is the risk-taking attitude. Number 2 is risk-averse attitude, and number 3 is neutral. Here, I represent each character by lambda. Risk-taking is lambda equal to 0.1. Risk-averse is negative 0.1, and neutral is lambda equal to 0. We used the same case study as just now, which is we have 4 attributes. It looks like for the risk-taking, it gives the same ranking as the previous result. But if we use the risk-averse, it gives a different ranking. I mean, different rank. And for neutral, there's no need to do with the computation. We just use the average number, because all criteria give the same values. So from this result, we know that risk-taking, I mean the attitude of the designers will give a different result to the final decision. So this is our challenge. So we don't know in the process of when the designer do a design, or when the designer make a decision, we cannot actually detect or identify whether when the decision is made, the attitude of the designer is in the risk-seeking or risk-averse. So to help them, I mean to improve the situation, that's why we come up with the new approach. Later I will explain. But before that, I want to show you. If we consider 2, okay, we did a case study on the crawler crane design. Okay, we have 2 conditions. One is risk-seeking, and the second one is risk-averse. We can see at the rank here, using the fuzzy topsis rank here, you can see that both character give a different value and different ranking. So it proves that different character will give different results or different decisions. So that's why, as I said just now, instead of just based on the first step, the first algorithm just now, we come up with the second step, which is the new assessment model. Okay, it is inspired actually from the Tan in 2011 and Key 2013, where we use the triangular intuitionistic fuzzy numbers. Okay, we use this to further improve the technique on how to deal with the designer's character or designer's attitude. So these are the steps of the new model. So we use the intuitionistic fuzzy number, and second one, we allow for more attitudinal information. We not just based on the the single data. We keep on getting the the information, the attitudinal information from the designers. And then we introduce the flexibility and adjustability function. As I said just now, maybe the different designer has a different, different environment, different nature of work. So that's why we have to include this flexibility and adjustability of the function. And of course, since I'm trying to integrate two different approach, two different models, so I, at the end of it, I have to reduce the computational step. Otherwise, it will be the method will have a very complex process. So these are the algorithm of the model. So basically, the matrix here is originally coming from the previous approach, and only but I only changed the contents of the matrix by considering the the geometric averaging. The weighted geometric averaging. So we have here two type of weighted geometric averaging. Number one is the operator weighted and geometric averaging, and the second one is the hybrid geometric averaging. So with these two, so I interpret the content of this matrix, okay, using the weighting vector criteria, okay, and finally we calculate same as the traditional, the conventional topsis, but in this case, I will added one techniques, which is we call it as a VCore techniques, because VCore can actually can compromise the conflicting or non-commensurable data, since, as I said just now, the designer or the human can give a different perception. So to deal with the weak data, so I try to include the VCore technique here. And finally, we will rank the alternative. Okay, so these are another design problems with 4 attributes. Okay, and of course, I have different criteria for each design. Okay, using the metric that I showed you before, try to compute this data, and finally, when we rank the alternative, okay, using the using the technique that that I showed you just now, it shows that this one is as I said just now, I'm using the triangular intuitionistic fuzzy aggregation operator, and then VCore, as I said just now, instead of just rely on the topsis, I'm trying to extend it using VCore method, and the final ranking. So I'll get that the A4 actually is the best alternative, right? And also, if you look at this, the lambda The lambda is actually the value of the attitude just now. I mean the attitudinal parameter that we already quantified. Okay, using VCOR or using matrix just now, we already embed into the matrix. So from this method, I mean the two methods that I showed you just now, the two models. Okay, I already take into account, okay, the attitudinal character of the decision maker by using exponential related function and the flexibility and adjustability parameter. And for the reliability model that I showed just now, it enables the detection and prediction of the root cause of failure, okay, which the study found useful at the early design stage. So it means that by using the proposed method that I showed just now, the designer can actually assess both the reliability and also the concept design stage by considering the attitudinal character of the designers. And this model actually simultaneously caters for the many interrelated attributes in the product development process. So it means that even though I'm just focused on the reliability and also the concept design, it is actually using the same technique. It is actually can also consider or cater the other factors in the product development engineering. And the design model provides a more holistic approach for expressing the design related information using using the triangular intuitionistic fuzzy numbers, which express the info in the several dimensions. And finally, I call these techniques, these two step techniques as AI-based techniques. It is actually, this technique actually provide innovative approach, which could support the launching of new product. Since the aim of this approach or these techniques basically to help the design to reduce the product development time and also the cost. So this study also provided two new AI-based techniques, as I said just now. Number one is the reliability. The second one is the concept design by including the attitudinal parameter. And then in the future, as I said just now, we intend to make a model user-friendly after some improvement. So my aim is to develop a decision support system. So we can make it in the, in simple, like, a software, so that it can help designer to simplify the process. You just key in the value and then they can get the final results. So these are some references that I use for this research. And I want to acknowledge for this research, basically I did with the, Dr. Daniel from Bell University of Technology Engineer. He's my co-researcher and also my ex-PhD students. Okay, he already did the PhD with me, I think the last 2 years. Okay, and also I would like to say thank you to Dr. Prasad for inviting me to this, seminar, and I'm very proud to, to deliver my lecture in this seminar. Thank you very much. I think that's all from me.
Thank you, Professor Bin. Thank you, Tura. Now I would like to invite Dr. Suresh to take on the session.
Yes, sir. Hello, everyone. Thank you for having me. My name is Dr. K. Suresh, Assistant Professor from Mechanical Engineering Department, GITAM. Thank you, Dr. Faiz bin Mohammed Turan, for delivering talk on reliability information to support decision-making for product development. It is always a complex process in decision-making while making a product development. It's based on multi-criteria decision-making. So you have touched upon all the methodology which are related to multi-criteria decision making by using TOPSIS method and institutionalistic fuzzy methodology and exponential related matrix, relative closeness, how to calculate the relative closeness, and what is the severity of occurrences, failure occurrences, and based on attitude, risk taking without taking risk, and being neutral, how we should make it by using crawler crane. You have explained very well, and I feel it is very much insightful presentation, and it is very much helpful and motivating for the budding researchers and engineers and people from academia and industry. And you have touched upon Vickers method and TOPSIS method, and by using fuzzy methodology, it is very much insightful, sir. Thank you for being an expert for our webinar series. On behalf of Mechanical Engineering Department, GITAM University, I'm thanking you, sir.
Suresh, 1 minute.
Yes, sir.
We have some queries, questions.
Yes, sir. We have some queries.
Please, kindly. Dr. Sandeep, can you coordinate with that?
Yes, sir. Sir, can you able to hear my voice?
Yes.
Yeah.
Please go ahead.
Sir, good morning, Quran sir. So here are some few questions related to the topic, which has been given by some of the participants. So I would like to post you some questions like, can you elaborate or giving us a glimpse of area in automobile where this topic model can be applied? And any more questions, sir? Can the topic model be implemented in math also?
Yes, can. Since it is a decision, it is generic. Basically, decision-making techniques that I'm sure just now is generic. It can be applied anywhere. If we want to say about the automobile industry, so maybe this method is suitable for the engineer to use it just before the mass production. So means that at the stage of the prototyping, I think that one will help much for the designer. I mean, since for automotive industry, basically when you the cost of failure if the defect pass through during the mass production is very huge. So that's why it is suitable before the product or the cars or the automotive the automobile can before the mass production. I think for this one, it's suitable for the engineer to use it during the embodiment stage of the design, like when designing the process or designing the process specification. It will help much to the designer to reduce the cost of failure.
Thank you, sir. Thank you, sir. Yeah.
And one more.
Yeah, another one question which we have from the participant, Professor Pradeep Kumar, sir. Which method is ideal for conflicting attributes?
Basically, it is a lot of it depends on the nature of your problems. Basically, the most common techniques in decision making, like TOPSIS, AHP, we have also VCOR. All of this method basically is suitable for any multi-criteria decision problems. So that's why first you have to identify the characteristic. Okay, I mean the character, the attributes, and then you have to relate with the criteria, your criteria, and also what you want to achieve. So if let's say the complexity of your if the problems, it relates to the, like I showed just now, it relates to the certain issues. So you have to translate, and then you have to check whether which method much more suitable. So I cannot say which one is the best, because it depends on the issues of your, the detail of your problems. Like mine just now, since the character of my problem, the characteristics of my problem is suitable for TOPSIS, and then when I want to embed or I want to integrate with the attitudinal character, it is suitable for Topsys, so that's why I choose Topsys. If some problems related, some problems suitable for AHP, you can choose AHP. It depends on the nature of the problems.
Thank you, sir. Thanks a lot.
I have received, Dr. Turan, I have received 2 requests, sir, from our participants.
Okay.
Sir, some of the participants, they are asking for one of your publications, 2 of your publications. Is it possible to share?
Sure. So I can share my publication. I will send it to you. Is it okay, Dr. Prasad?
Yes, sir. It is very much fine, sir. And one of my colleagues and few of my colleagues are asking your presentation also.
No problem. I can share with you.
Okay. 2 of your publications and presentation is required, sir, so that I can share with everyone.
Okay. Noted.
Okay, sir. So, on behalf of Mechanical Department, we were very much happy to be here, sir. Thank you for accepting our invitation with a short notice. And thank you for promoting our event in Malaysia and Vietnam also. Maybe because of your sharing, we received participation from abroad also. Thank you for sharing our information and promoting our institutional activity. And in future, we would like to collaborate with you, sir. Whenever we get a chance, we will try to collaborate with you, sir. And based on the feedback received from Q&A, our audience, participants are very much happy about your presentation. Thank you for being part of the GITAM event, sir.
Thank you very much for inviting me.
Thank you, sir.
Thank you. You're welcome.
Okay, sir. Thank you very much.
You're welcome.
Thank you, sir.
If you wish, you can stay in the session, sir. As a panelist, you can stay till whatever the time you are going to require. Now, I'm going to play a small video about the GITAM. Then Professor Venkatrao from GITAM Vigyan University will start. Now, sir, I think Professor Venkatrao is in the panel now. Dr. Venkatrao, can you hear me? Professor Venkatrao from Vigyan University?
He's not there, I think so, sir.
Okay, sir. Turan, sir.
Joined.
Okay. I think he is appearing in the panelist. Not yet joined? Okay.
Not yet joined, sir.
His session is scheduled at
not in the list.
No problem. No problem. No problem. Okay, sir. Dr. Turan, thank you, sir. Suresh, echo is coming, huh?
No, sir. No. No echo. No echo.
Thank you, Turan.
Thank you, sir.
Okay. Bye. Okay.
Hello, sir. Good morning, sir.
Chapal.
Sir, make it full screen.
Full screen,
Full screen, sir. Make it.
How?
Right, sir. Up to video. Video.
Now I think it is okay. Dr. Adas, thank you. Is it visible?
Yes, sir. It's visible.
campus is really good. There are very good opportunities for research here, which is the basic thing. So if anybody is interested in PhD, because there are a lot of UGC grants that are there in this college. So it's really great for research.
The Lakmundur life was very different. I was not able to express myself. Like it was very different. Geetam vachin tarvata, my life is totally changed. I don't know ee change anedi nenu elag express cheyalenu because it gave me
University.
Hello.
ఈ గీతం యూనివర్సిటీ ఉన్న కాలేజెస్ ఎన్నో నాకు ఉన్నది వాటన్నిటిలో కొద్ది కాలంలో #1 ప్రైవేట్ యూనివర్సిటీగా వెలిగింది అంటే
I was coming into the university and I was really impressed with the infrastructure. Fabulous infrastructure.
GITAM University.
Good morning, Professor Venkata. Can you hear me?
Yeah.
Okay, sir. Sir, are you ready with the presentation? I want to play some video about the GITAM. That is.
Okay. Play it, no problem. You start as per the schedule time.
1 or 2 minutes, sir.
Okay, no problem. Doesn't matter.
Sandeep is here with me. Sandeep
Puller, sir.
Okay.
Sir, Sandeep Leru.
Okay, no problem.
GITAM recognizes the relevance of Mahatma to all disciplines, ranging from medicine and law on the one hand to philosophy, architecture, and other humanitarian disciplines.
With an expert and dedicated faculty, great infrastructure, a vibrant campus, and a plethora of core and elective papers, this institute proves to be the best.
It is great honor for me to receive the prestigious GITAM Foundation Award. Thank you very much.
గీతం యూనివర్సిటీ ఉన్న కాలేజెస్ ఎన్నున్నో వన్
Fabulous infrastructure.
All the three campuses are well equipped and the best in their academic pursuit.
Good morning, Professor Dr. Venkatrao.
Good morning. Good morning.
Good morning, sir. Welcome to the GITAM, sir.
Thank you.
Because yesterday you have attended for our inauguration function.
Yes, yes.
I don't want to get into the deep into the details of the mechanical engineering department.
Yeah, yeah.
It is my hearty welcome GITAM event, sir. A two-day virtual seminar series on exciting advances in manufacturing automation. And I personally thank you very much for accepting our invitation within a short notice for delivering the invited talk.
Thank you.
We have chosen you because you are one of the best in the manufacturing. If you consider the last 5 years trend, his last publications, if you consider the 15 publications, out of 15 publications, he has published more than 12 SCA journals. He is
No,
in fact
20 SCA.
Okay, sorry.
21.
I'm considering on the last couple of years data.
Okay.
Okay. So before starting the actual your talk, I just want to show the only the slides about our department. Department of Mechanical Engineering credentials.
Yeah.
Only for the because few participants joined recently along with your immediately after you joined, few participants are joined in the session.
Okay.
For the benefit of the newly joined attendants, I'm playing these particular slides.
Okay, sure.
Quickly, I'll move into the slides there. I have chosen a wrong file. Suresh, can you play that PPT? The document is with you. I'm closing everything. 1 minute, sir. Professor Ravi Shankar is there? Hello? Hello, Professor Ravi Shankar is there?
No, sir, he is not there.
Sandeep, are you with me? Dr. Sandeep. Adarsh? Suresh? Adarsh?
Yes, sir.
Are you in the class now?
No, sir. Just now I came from class.
Okay. ఒకసారి సురేష్ మన రవిశంకర్ గారికి ఒకసారి కాల్ చేయాలి.
Okay, sir. Okay. I'll call him.
Audience, please wait for a few minutes. We are waiting for one expert, professor. Kindly bear with us. Dr. Adarsh, can you call to Professor Ravi Shankar once?
Yeah, okay, sir. 2 minutes. Sir, BSP sir. Hello? Hello, BSP sir?
Others, tell me.
Sir, due to some technical issue, just Ravi Shankar will join in 2 more minutes, sir.
Okay. We'll wait for him.
Okay, sir. Okay.
Good morning, sir.
గుడ్ మార్నింగ్ వెంకట్రావు గారు.
Good morning, sir. How are you?
బాగున్నారా?
బాగున్నా సార్, మీరు ఎలా ఉన్నారు?
సూపర్ సార్.
Thank you, sir. It's very honor to me.
థ్యాంక్ యూ. ఇంకేంటి సార్, ఎలా ఉన్నారు? ఎక్కడ విజ్ఞాననా?
విజ్ఞానే సార్.
ఓకే. మావాడు ఎలా ఉన్నాడు? చంద్రం
వరంగల్ కదా?
అవును, ఎలా ఉన్నాడు?
ఫైన్. He is in touch with me.
ఓకే. ఇప్పుడు ఎక్కడ ఉన్నారు రైట్ నౌ మీరు?
నేను
విజ్ఞాన్.
Good morning, sir.
Sir, good morning, BSV గారు.
Sir, thank you, sir. In spite of your busy schedule, thank you. I think
బిజీ షెడ్యూల్ కాదండి, పవర్ పాయింట్స్.
అవునా సార్, అదే సార్, మీరు అకాడమిక్ కౌన్సిల్ మీటింగ్ లో ఉన్నారేమో అనుకున్నాం సార్.
లేదు, పవర్ పాయింట్.
ఓకే సార్, ఎవ్రీథింగ్ ఓకే సార్. కెన్ ఐ స్టార్ట్?
మీరు స్టార్ట్ చేయండి ఒక్కసారి. నేను ఆదర్శతో మాట్లాడాను ఒకసారి.
ఓకే, ఐఎమ్ గోయింగ్ టు డిస్ప్లే ద కంటెంట్.
ఓకే.
Okay, sir. Professor Venkatrao, are you ready, sir?
Yeah. Ready.
Dear audience, now I would like to request Professor H. Ravi Shankar, Professor in the Department of Mechanical Engineering, to introduce our fourth invited speaker, Professor Venkatrao from Vigyan University.
Okay, sir. Yeah, I take it as a privilege to introduce Mr. Venkatrao. ఒక్క నిమిషం అండి.
Yes, sir. నేను అంత కొంతసేపు డిస్ప్లే చేస్తాను, మీరు ఎప్పుడు కావాల్సి అప్పుడు స్టార్ట్ చేయండి.
Yeah, it is. Can I start, BSP garu?
Yes, sir. Please go ahead, sir.
Yeah. Good morning, all of you. And I feel it is very privileged to me to introduce Mr. Dr. Venkatrao garu, Department of Mechanical Engineering, Vigyan University. And he worked in the manufacturing area, and he published so many international journals. And recently I have seen in Facebook very highest impact factor journal he has published. Congratulations, Ante Venkatrao garu.
Thank you, sir.
Basically he is also very good friend to me. And he's published almost 50 international journals in very reputed journals. And he is serving right now as a professor. And he is guiding PhDs, 7 guidances there. He handled 3 research projects and so many conference organized by him. And he is almost delivered 10 lectures, 10 guest lectures around. And most of the best teacher award by Vigyan Foundation, best research award by Vigyan Foundation, and outstanding contribution in receiving by Measurement Journal elsewhere. And recently, in addition to that, I think Clean Production, sir, that journal, what have got...
Journal of Cleaner Production.
Yeah, he got very good impact factor journal. Recently, he published once. With this, I request Professor Venkatrao garu to start the session.
Okay, sir. Thank you, Professor.
Thank you, sir.
Thank you, sir. Thank you.
Sir Venkatrao garu, I am going to display your presentation so that you can start.
Can I handle that? That is, can I move that? I can move the slides.
Yes, sir. Please go ahead. If everything
Okay.
is available, ready with you, you can continue.
Okay.
Please share the screen.
Okay.
If any trouble comes, I will assist you.
Now, is it visible to you?
Yeah.
Yes, sir.
Okay.
Okay, sir. Please proceed.
Okay. Before going to the session, thank you very much. Good morning to all the participants, and I heartily welcome the participants to this presentation. I would like to convey my sincere thanks to Dr. Ravi Shankar Garu for his nice introduction of me. I know him very well since 2007 when he was at NIT Warangal. He is a friend to me. I feel honored for the presentation, that is the introduction of me by him. I feel very happy. After that, I convey my sincere thanks to Dr. B.S. Prasad for inviting me to give my presentation in this series on additive manufacturing. And I also extend my sincere thanks to HOD of GITAM Mechanical Engineering Department and the management of GITAM. Before starting this session, I would like to convey my sincere thanks to our beloved guide, my PhD guide. He belongs to GITAM University. Is Dr. B.S.N. Murthy Garu. In 2010, I registered my PhD at JNTU Kakinada under his guidance. I was able to complete my PhD within the stipulated time, that is in 3.5 years, with 4 SCI journals. Thank you, sir. It is the occasion to me to convey my thanks to you. Thank you very much. B.S. Prasad?
Please continue, sir.
Okay. So today, my topic is modeling and optimization of wall or well bed geometry and optimization, minimization of power consumption in additive manufacturing. So in that one, we use 2 techniques. One is PEM simulation, that is that additive manufacturing. It is not new. Everybody knows that one. If you see the additive manufacturing, we see it is a new technique. It is not new technique. This is the metal additive manufacturing. It is same as the conventional welding process. It may be either gas metal arc welding and tungsten, that is tungsten inert gas welding. Either one of the technique is used in the additive manufacturing. Before seeing the starting, let us see what are the optimization techniques we have in mechanical, in engineering, especially in the manufacturing engineering, and modeling technique. Just a brief introduction of these optimization and modeling techniques I will give. After that, what techniques we used in this presentation, that one also in detail we'll see. So I'm not going the peripheral thing, peripheral on the additive manufacturing like that. Here, I took one example as that our Ravi Shankar told that the work which was published in the Journal of Planar Production. I think you might be knowing that one. Its impact factor is 7.246. Highly impact factor journal. This is highest impact factor journal in production. Okay, where recently I published that one. Same topic I took for the presentation. It will be benefited to the participants to carry out that work. It may be inspiration to them. Oh, how simple work we can present, publish in the top impact factor journal. It may be inspiration. Before that one, these optimization techniques will have different optimization techniques. Generally, we are using this one, Taguchi method, response surface methodology, gray relation analysis, particle swarm optimization, genetic algorithm, simulated annealing, and ant algorithm. Not only the 7, more than the 7 we have. that is teaching learning optimization technique TLPO of the J algorithm. Next one is graph theory and matrix approach. Not only this one, we have other optimization techniques. Generally, we follow this one. So in the Taguchi method, it is single response optimization technique. Everybody knows that one. For suppose in manufacturing metal cutting, if you see where the input parameters are generally cutting speed, depth of cut, tool nose radius, rake angle. These things we are taking as the input parameters, and they generally that responses are output parameters are surface roughness, cutting forces, tool wear, metal removal rate. These things we are taking as responses or outputs. So in the Taguchi method, you cannot find optimum set of input parameters for all the responses. So it is not possible. This Taguchi method is single response optimization techniques. So the optimum condition which for surface roughness may not be optimum for the tool wear. Like that, here we have complex and confusion here. So if you see this response surface methodology and gray relation analysis, these two are the multi-response optimization techniques. So most of the papers, if we see in that manufacturing technology, we see these two techniques, that is RSM and gray relation analysis. If you search for 10 papers out of 10, you will see more than 5 with RSM. So here thing is that in RSM, it finds optimal working condition for 4 or 5 responses. The same set of optimum working condition, that is input parameters, are optimum for all the output parameters. So no problem in that one. Even in that GRA method also, in GRA method, first we integrate the responses, more than 2 responses. They are integrated as to one response. With respect to that one, again we are using the Taguchi method to optimize the process parameters. The difficulty in that one, see this in the response surface methodology and GRA method, all the output responses are given equal weightage. Say for suppose there are 4 responses, say surface roughness, tool wear, metal removal rate, and cutting force. One cutting force we are taking. So 0.25, 0.25, 0.5 like that. Equal weightage is given to that one, even in the GRA method also. We don't know what is this weightage also. Default, the 4 or whatever the number of responses, all those things are given equal weightage. For suppose if you see the manufacturer, he doesn't, most of the times he doesn't bother of the quality of surface roughness and other things that consumer requires more. He concentrates only on metal removal rate and the power consumption. If you see the end consumer, he looks after the product quality. Like that, if you consider the consumer, he needs the good quality, that is surface quality, those things he needs more. If you see the manufacturer, to reduce the production cost, he wants to improve the metal removal rate and reduce the tool condition. Like that, importance to the responses will be varying. Those things are not considered in the RSM and the GRA method. If you see the particle SAM optimization, where we have set of experiments we will conduct. So as per design of experiments, you may conduct more than more 9, 16, 12, 27, like that we have design of experiments. In this design of experiment, the particle SAM optimization, what it will do, it finds the experiments which are having as per our requirement, that is the experiments which are having good surface quality and better tool life. Those things will be grouped at one place. But among that group, it will not identify which is the best one. That is the problem with particle SAM optimization. Even if you see the genetic algorithm, simulated annealing also, where we will find out one objective function. In that objective function, we have one formula. In that formula, all the response are included. Based on the objective value, they select one best condition. So these two are genetic algorithm, simulated learning we are seeing since 50 years. That is why there is still we are using with some modification. But generally in our manufacturing we are using first three methods. So ant algorithms also recently people are using. That is about the optimization techniques. But all these optimization techniques did not address, they're not able to address not able to provide weightage to the responses. So that for that one, you have graph theory and matrix approach. Later I will tell. And another one is the teaching learning based optimization technique. Actually, it was introduced by Ravipudi Venkatrao. He is professor at NIT Surat. He developed that technique. Now, thousands of people across the world using this TLBO technique. So now it became very popular. If you take the TLBO for your optimization problem, that in this presentation I am going to explain that one. TLBO I am explaining to optimize the power consumption and additive manufacturing parameters. In detail we will see about the TLBO. It is a very good tool. With that one, even in that journal of planar production, I use the TLBO. So you can, I will step by step, all the steps I will explain. You can understand it very easily. So TLBO and GTMA, these two methods address that is giving weightage to the responses as per our requirements. No need to feel confusion. In detail, you will see in the next slides. Now, after that one, we see modeling techniques. Modeling techniques, they develop a relationship between inputs and outputs to predict the outputs for a given set of inputs. Taguchi method, it is the optimization technique as well as the prediction technique also. Most of you know that one. Once if you find out the optimum process parameters, if you give that optimum process parameters to the software itself, so it gives the responses. How it gives, if you say, or suppose there are three input parameters, cutting speed, feed, and depth of cut. So each one is with the three levels. So 3 cutting speeds, 3 depth of cuts, 3 feed rates. The Taguchi method gives only 9 experiments. Actually 333, you should perform 27 experiments. Out of 27 experiments, the Taguchi suggests only 9 experiments to carry out your research work. If the Taguchi method finds the optimum working condition, so beyond this 9 experiments, now what we have to do, we cannot go for the experimentation to conduct that one. So actually, as per Taguchi design of experiments, we conducted 9 experiments. So remain 18 experiments we didn't conduct. If the Taguchi finds optimum working condition in that 18 experiments, what we have to do? So Taguchi provides, if you give the if it finds the optimum working condition beyond the 9 working conditions, that working conditions, if you give this Taguchi, it gives the output value for that. Similarly, response surface methodology also. This is regression analysis. Everybody knows this one. So it gives, say, Taguchi will not give any equation between the equation form. It will not given for the responses. Response surface methodology it gives quadratic model. It will give 2FI model. It will give linear model. It will give for the responses. That is for the outputs in terms of the. So regression analysis. Okay, in Minitab, all these things, most of the things we can perform using the Minitab and Design Expert. Design Expert, another software people are using. It gives colorful surface graphs. That's why you can use both are same. In the regression analysis also, it gives the equations, that is mathematical, that is in terms of inputs, it gives one equation for the responses. So mathematical modeling, this is similar to the regression model. Mechanistic models also, some like mathematical, that is semi-analytical technique, that mechanistic models. And these 1, 2, 3, 5, and 6. So in this Taguchi method, response surface methodology, regression analysis, mathematical modeling, and mechanistic models. So in addition, 7th one, we keep the 4 simulation side. So artificial neural network, it is one kind of technique in the machine learning. Excuse me. So the seventh one, artificial neural network is a machine learning technique. So inside, so we are giving the set of inputs along with the outputs. It develops a relation inside the software, and if you give any input, it predicts the output. So Taguchi and artificial neural network, it will not give any equation to you. But response surface methodology, regression analysis, mathematical modeling, mechanistic models, where you have the equations for the responses in terms of the inputs, you can find that. Okay, all these except fourth one, all these things are data-based modeling techniques. What is the meaning of data-based modeling? The data which you got through the experimentation. The data which you got through the experimentation. So it develops one equation or relationship between the outputs and inputs. After that, it predicts the outputs. If the experiments, if you not conducted properly, okay, if you perform the experiments accurately, well and good, the prediction will also be good with good accuracy. But if you, because in the 1, 2, 3, 5, 6, 7, we are developing the relation using the experimental data which we collected. If you perform the experiments well, the results will also be good. If you not perform the experiments well, that relationship, that is, it will not predict the outputs well. But thing is that all these techniques will predict with the less time. Simply, if you type the inputs, it gives the outputs. It won't take not more than 1 minute. In seconds, you will get the predicted values. But FEM-based simulation is not like that. So where you have the different types of softwares in the okay, most commonly we are seeing the ANSYS. In addition to that ANSYS, based if it is machining process, where you have deform 2D, deform 3D, advantage, abacus, like that we have different simulation techniques. Similarly for the farming also, and welding. So like that we have different types of the modeling techniques. So what is this FEM-based simulation, that is finite element modeling based simulation? So all remaining things are the database. It is physics based modeling technique. So inside, so you have that if you give the input and output inside that software consists of the material library. From that material, it selects the properties of that one and it performs. If it is machining process, we have to define what is the workpiece material, what is the tool material, what is the tool geometry, speed, feed, depth of cut, all the input data we give, and it runs the simulation. So based on that, all the that mechanical properties will be considered while simulating the machining process. So finally, it predicts the output characteristics accurately. Most of the times, we can believe the results given by the FEM-based simulation. We can believe that results given by the FEM-based simulation. But thing is that each experiment, it will take more time. So sometimes it takes days also, 2-3 days also. If you see the deform 2D or 3D, it take more than 2 days also. That is the only problem with this FEM-based simulation. So in the present study, we have taken FEM-based simulation and supporting the to validate the that TLBO, teaching learning based optimization technique. So my study is in this presentation modeling and optimization of wall geometry as well as the power consumption in additive manufacturing. Before going to that one, some of the innovative works which were done by me, and I am not disclosing my researchers' work. I am leaving that works to them to present their work some places like me. That's the works which were handled by me. Those things only just 5 minutes each. Only I am presenting 4 to 5 slides about my innovative works only, not all the things. So if you see, this is very innovative work which was published in Journal of Allies and Compounds. Its impact factor is around 4.6, and that one also mentioned here. In that work, what we did, generally we are seeing the cutting forces are affected by the machining conditions like cutting speed, feed, depth of cut. So most of you do not know there is another factor which is greatly affecting the cutting force, that is the dead metal zone. See, the study on effect of dead metal zone on tool vibration, cutting and thrust forces in micromilling of in column 718. If you see in this figure where we have one zone, that is the dark zone, that is ADF. This zone is called as dead metal zone. It is not visible unless you have a high-speed video camera. It is not possible to see this one. To see this one, this is dead metal zone, ADF. If the size of dead metal zone is more, so there is effect of dead metal zone on the tool is more. So to avoid that one, you see this one, this is R is the nose radius. So to reduce this dead metal zone, you can keep the R value as 0. So that means the tool will be very sharp when it is used against the rotating workpiece, or when the high cutting force is applied on that sharp tool, it will be damaged. That's why there you must use the nose radius to improve the tool life. If you use the nose radius, you will get the dead metal zone. So in 2008, one researcher he tried to find out the effect of dead metal zone on the cutting forces. After that, 2008, nobody touched that concept. In 2019, I say we tried, and here also we are not able to measure this dead metal zone physically, but concept of using the below figure, that is deformed 2D. We used the deformed 2D, found the dead metal zone. See this one at the bottom, you have angle of dead metal zone, size of the dead metal zone we found, and there are equations in terms of the dead metal zone for the cutting and thrust forces. We found them and we compared with experimental result. Okay, obviously we got the error less than 5%. This is very innovative work. Anybody can try in our research work also. So another innovative work. This is also very limited study was done on the effect of wire vibration on cap width and surface roughness. So for the surface roughness, we have the mathematical models to find out the surface roughness using the vibration in X and Y direction. But here, cap width, it is difficult to model. So in this study, myself and another my colleagues at Vignan University, we developed mathematical relations using the wire vibration in X and Y direction. So bottom one, see, this is not my work. This is another researcher's work. They used a high-speed video camera to measure the vibration of wire in X and Y direction. But they failed to measure the displacement of wire in X and Y direction simultaneously. That's why at the one particular time, you cannot synchronize the displacement of wire in X and Y direction. That's why in this study, it was very difficult to, we faced many difficulties to measure the wire vibration in X and Y direction using the accelerometer. However, finally we got success and we measured, and the measured value were compared with this bottom bar. So we also conducted the experiments where that bottom work, they conducted same working conditions. We performed the experiments and compared with that one. After getting the confirmation, then only we used the accelerometer for our the work, and we developed the mathematical. Those things I didn't, I'm not present here as the time constraint is not my topic also. This is also very innovative work. Anybody one can do. And this one is another innovative work considering the this is the helical milling, where we measure the vibration of tool in X, Y, and Z direction using the amplitude and frequency of tool vibration in 3 directions. we developed ourselves, we developed that is the mathematical models for the circularity. So this one was accepted in SCI journal, had to be published in SCI journal. See this one in the fourth figure, where we got this one is the polar graph. So that is we predicted the circularity at the worst working condition. Say from this one, the extensive work, anybody else, if you want to carry out, we can carry out using the gray modeling prediction, gray prediction technique, GM11, GM12, like that. We have mathematical models, gray models. It doesn't take more than 1 week. Easily you can see that one gray prediction model, GM11 or GM12. Using that is time series. Using that one, you can predict the cylindricity also. Here we predicted only the circularity. You can predict the cylindricity also. I think you got to understand that one along the length of the workpiece, you can find out what is the errors in the cylindricity during the machining process. You can predict. This is one of the predictive work, and this one is another one. Most of the this is I told you giving weightage to the graph theory and matrix approach, finding the weightage to the responses. These are the if you say bottom, we have one graph, reference graph, this one, low to high. So using this one, this is where we have 4 different users. Based on the 4 different users' opinion, user A, he gave high priority surface roughness. After that one, tool wear, like that, and the amplitude of vibration. RQ is another surface roughness measuring thing. So based on the preferences of different users, no need to constrain to 4. You can consider 40 also. We are based on the collection of opinions of different people. We can scientifically find out the weights to the responses. So this work also we done for 3 papers we published using GTMA in SCI only. This is also Journal of Alloys and Compounds High Impact Factor General. And this is another one where you use the this is advantage software for this is ball and milling. Ball and milling, where we are generally this kind of ball and milling we use it in the fabrication of dice. In the dice, at corners you have the sharp corners. It is generally we need the corners should be smooth. In a regular end mill cutter, if you see the bottom of regular end mill cutter, it is flat. So that's why you cannot get the round corners in the die cavity. To get the round corners, you must go for the ball end milling. So when compared with flat end mill cutter, these ball end mill cutters, the cutting zone is more. So when the cutting zone is more, it there are associated with more cutting forces and power consumption is also more. So here we use the same PLBO technique to reduce the power consumption. It is published in the measurement. Everybody know the GITAM University. Most of you know about the measurement journal. Now its impact factor is 3.36. Okay, these are this is another innovative work. This is the friction stir welding done by me, where we used I used the deform 2D 3D integrated. So we have deform 2D 3D. We have deform integrate 2D 3D option is there in the deform software. Using that one, we can simulate the welding process. Also, it was published in the Brazilian Society. Okay, now this is the last one is recently done. August 25th, it was published. The work was done by me. This is actually we have another work in that the same quality. It is under yet to be published. That is yet to be in the review process. It is okay. This is done by me. Its impact factor is 7.246. In production, it is the highest impact factor. Okay. Now the work which I am presenting, that is which I published in the cleaner production. Now you see. In the developing countries like China, now actual work presentation I entered. Please listen carefully. developing countries like China, India, South Africa, Brazil, Sri Lanka, and these countries, in those countries, the power consumption doubled since 2010, especially in the manufacturing sector. So in the manufacturing sector, even in most of the developing countries, the 25% of share in the country, that one development, that is from the GDP. From the GDP, 25% share is occupied by the manufacturing sector. So when the manufacturing sector is here, the power consumption is also more. So when the power consumption is more, what happens? There we have environmental impact also. So when the demand for the power is more, so to meet the demand, we are producing the excess power, and where it gives simultaneously, proportionally, there is impact on the environment. So here we want to reduce the amount of power consumption. If you see in the metal manufacturing industries, there are many subsystems in that power. So for suppose if it is a machining, that the manufacturing industry, most of the machines are machining, that is metal cutting machines. For suppose in that industry we have. In addition to that one, we have material handling system and coolant system. Like that, we have some subsystems. So we have to find out where the wastage is more. So we have to find out the wastages, and if we concentrate on that one, the power consumption can be reduced, and finally, indirectly, environmental impact can also be reduced. So in this, keeping this power consumption in the view, quality of product we have to develop. So not only reducing the power consumption, so quality of product is also important. So here, if you work, if you perform the manufacturing accurately, it doesn't require the rework. If you not done properly that working, so you are keep on going repetitive works to improve the quality of that one. So if you optimize the process, it reduces the reworking. When the reworking is reduced, generally the power consumption can also be reduced. So keeping all those things in that view, the process parameters are optimized in this part. Quality of weld or wall geometry. This one is additive manufacturing, where the wall is made by just like weld bed. So one weld bed on another bed, like that, layers, layer by layer. We are constructing the wall geometry. That is the one pass over the another pass, one pass on the side based on the thickness of the wall. So side passes are one by one passes are building. So like that, we are producing the components in the additive manufacturing. So this additive manufacturing is similar to the conventional welding process, and the electrical power plays an important role in performance of the additive manufacturing with respect to cost, time, and quality of the parts. So in additive manufacturing, there are several subsystems like wire feed system, energy supply system, cooling system, motion control system with software. Like that, we have different subsystems. They are consuming the power along with the additive manufacturing. The additive manufacturing is similar to conventional welding. So where the arc is generated between the wire electrode and the workpiece, then the spark or the arc consumes power to melt the wire electrode. Everybody knows that arc welding, that's why that was not included here. Some of the components, see the quality of the components, some of the components made by the additive manufacturing. See in the first figure, circular component manufacturing, and other complex shapes can also be made by the additive manufacturing. So most of you know that one. So first we build the component on the solid modeling. After that one, the component is made in slices. So each slice thickness less than 1 mm. So in the additive manufacturing, everybody knows that one. Most of you know that one. Layer by layer, just like slices, the work will be done in the conventional additive manufacturing or 3D printing most of this. So in additive manufacturing, it is not like that. Concept is same. So here also layer by layer, but layer is not less than 1 mm, more than 1 mm. So that is up to thickness of each slice more than 5 mm. So like that we have in the metal additive manufacturing. Here our aim is to control the wall geometry quality. That is the wall geometry, that is thickness and height, optimum thickness and what is the optimum thickness height. So as per my requirement, I need the thickness of the wall should be 6 mm or 5 mm, or not more than 5 mm, not more than 6 mm. Like that, we have the constraints. According to constraints, that component is to be made. The constraints also in details we will see in the next slide. So what are the advantages with the additive manufacturing? As the metal is directly deposited in layers, waste of the metal is minimized and efficiency of the process is improved around 75 to 85%. So generally, if you want to make a complex shapes, there is loss of removal of material, loss of time it is taking. So there is for some complex shapes, if you see this one, for the second figure, if you want to make, first you have a cylindrical disc like that. After that one, the lot of material is to be removed. So if you go for the additive manufacturing, directly layer by layer we can make. So as we have seen, 75 to 80% of wastage is minimized. So where in this figure, if we say a lot of material is removed, so it is taking time, it consuming more time. All those things can be minimized in the additive manufacturing. So nowadays we are using the robots in the additive manufacturing. They are able to just at the robot arm we are giving the touch, and the robot is programmed. It moves in X, Y, and Z direction. It is able to fabricate complex and large components. See, this kind of parts can be made by the robot. So weight more than 10 kgs with high melting point like titanium, inconel metals, those things can also be fabricated using this robot-based gas metal arc-based welding technique in the additive manufacturing. Though this additive manufacturing is having many benefits, still it is required to optimize the power consumption because the additive manufacturing melts the metal at high temperature. So here it consumes more power than the cutting forces. That's required to optimize the power consumption. So these are some of the previous research works where they found difficulties. If you see the first one, generally while we are doing this robot-based arc welding in the additive manufacturing, at starting, see this one seems to be swelling. At the end of this one, where you have the reduction, it is the common problem to everybody. This can be sorted out by controlling the process parameters at starting and end. See this he et al. He proposed some control working conditions at the starting and ending through the technique. We also able to see this one. This is the second figure obtained by us in our work, where at starting and the ending there is no much variation in that one. The technique which we followed, same technique we followed, that the swelling at starting and reduction at the ending are sometimes we can completely control down. So another thing we have to look into this one, that is arc force. See this one. This work was done by the Lee et al. He performed the welding. So in that additive robot, this was published in the robot-based computer integrated manufacturing 2019. It was published. So he studied on molten pool, that is weld pool stability of thin wall parts in robot GMA, that is gas metal arc based additive manufacturing, with various position deposition. So where he conducted the experiments at 60 degrees, 90 degrees, and 120 degrees. So 60, 90, 120. See this one at 60 degrees of touch angle. See, he kept the touch angle. And first one is he kept the touch angle 60 degrees and moving. See this one, that weld bed takes place backward for this one. And second one, if you see, the arc force is directly applied on that weld pull. See this one here, the angle of the torch is kept 120 degrees, where the arc force is applied on the weld bed. The metal is deposited. See this one in the first figure, arc force. So see this one, the arc force. This is applying on the workpiece material beyond the that is the weld pole. Second one, see this one, where the arc force is applied on the workpiece exactly at 90 degrees, where the effect of arc force completely on the weld pole. See this one in the third figure, effect of the arc force, that is F3, is acting on the metal deposited. So what is happening? In the first figure, arc force F1 is acting on the workpiece. In the second one, arc force is acting on the weld. In the third position, arc force is applied on the weld material deposited. So based on that one, if you see in the first figure, see that is height of the metal deposition is less. And the second one, so height of the metal deposition increased from that one. In the third one, height of the metal deposition is high. See this one, you can H1, H2, H3 increasing. What happens at H1? Width of the metal deposition is less. Say if you see weld bed, width of the metal weld bed is less here. In the first figure, width of the weld bed is more. In the second one, width of the weld bed is medium. So finally, he optimized the process parameters and conducted some analysis work, and finally found the touch angle which is less than 90 degrees gives better weld quality or wall geometry. In my work also, I performed the experiments at 60 degrees and 90 degrees. This is another study done by the Yang. This was published in Journal of Material Processing Technology. He used the double electrode. One is metal electrode and tungsten electrode to reduce the arc force on the molten pool. But the this experimental setup is difficult for us. So always we try to simplify our work. We not go for complex. So with simplified experimental setup, simplified work, we should get the maximum. This is the aim of the mechanical engineer or methods engineer or production engineer. So the setup should be simplified, the machine should be simplified, and the more results. That's why where's the difficulties where we have. So this is already this slide we explained in advance. So now, so in that presentation, we studied the effect of arc force on the that is thickness, width, and depth of the weld bed. So what are the forces in that metal transfer? If you see, where we have different theories we have, that is for metal transfer. What is this metal transfer? Generally, in the second year in manufacturing technology, in gas metal arc welding, that is the metal inert gas welding, where we have 5 types of modes of metal transfer: short-circuited, globular, spray, pulsed, and rotary spray. Like that, we have 5 types of modes of metal transfer. In all those things, that how we are getting based on by increasing the, we can get some globular to spray, rotary spray. Like that, we are getting pulsating spray. We are getting different types of modes of metal transfer. What is happening there? So like the different types of theories where we have, among that one, in this one, I took the static force theory, which describes the detaching of molten metal, that is drop from the metal wire electrode. So this work was done by Kim and Eger in 1993. So where that we have filler wire, that is electrode, and electromagnetic force at top, which tries to detach the molten metal from the wire, gravitational force which pulls the drop. So when the drop is growing while melting, the gravitational force, when the size comes to some certain weight, automatically by gravitational force it will fall as drops. So next one is plasma force. We are getting from the using that plasma. Generally, arc is nothing but the plasma. It is incandescent stream of ions. So between the workpiece and the electrode, incandescent stream melts the workpiece, that is electrode material as well as the workpiece material, to mix these two thoroughly to get the joint that we have seen in the manufacturing technology in the welding process. So as shown in the figure, electromagnetic force, gravitational force, and plasma drag force are associated with the detaching force to detach the drop, while surface tension force act as drop retaining force. So that some of these forces should overcome the surface tension force to detach the drop from the electrode, that is consumed metal from the electrode. So these are the electromagnetic force, that is depends on the current. This one is gravitational force. How to find out this gravitational force? That details given here. So here also this is the plasma stream force. So all these things are taken from the standard values are taken based on the previous researchers. And finally, the total arc force is sum of electromagnetic force, gravitational force, and the plasma force. Sum of these three. So what is the effect of this total arc force on the wall geometry was studied in this present study. So this one is after performing the welding or additive manufacturing. See this one like this. Across this specimen we cut, and this is placed under the microscope and measured the size of this one. So that is this is weld pool, width of weld pool. This one is the height of metal deposition. This one from here to here, it is the width of that one. So profile of this one. So generally geometry of profile of metal deposition is on substrate. Substrate is nothing but the plate where we welded. Is defined different studies using as parabola and arc and cosine curves to study the effect of process parameters on the bed profile. So as shown in the figure, bed profile seems to be symmetrical and it is modeled with parabolic function given in this equation, where xy are the coordinates on any point on the parabola. H is the height, A is constant. This equation everybody knows in that manufacturing technology who are seeing this one. Now, in this process, we model the, we simulated the metal deposition on the substrate using finite element modeling. That is, we use it in the study SimFact welding. This is very simple. You can download from the net, and where we have manual, that manual step by step, not only for the arc welding, for the gas welding, fillet welding, corner welding, different types of lap joint, butt joint, even you have the resistance welding also. In that SimFact welding, detailed procedure we have manual. From that manual, you have to select one plate as substrate. This one is substrate, and one plate, one is bearing. Bearing is nothing but bottom plate is called as bearing. 4 clamps. These are the 4 clamps to clamp the substrate on the bearing at 4 places, and one robot is to be selected. All the things you have listed. From that list, you have to select one plate, one bearing, 4 clamps, so one robot. You have to select from the list. The substrate, see this one, the substrate is clamped on the bearing at 4 corners with a distance of 20 mm for each. And this size of the substrate is 100 by 100 taken, where you have the facility to change the size of that one also. These the clamps, height, diameter, even the shape also. Here we took the round shape. You have square, rectangular, hexagonal, different shapes are also there. As per our convenience, you can select, and the position of these things can be adjusted. Very simple. You can learn this one within 1 day if you follow the manual accurately. And now the this substrate is clamped on the bearing at 20 mm per edges. Now the substrate and filler material are assigned with mild steel. Here we use the mild steel. So substrate is mild steel and the wire material is filler material, but wire electrode. That one is also mild steel. You can take any one. So bottom one you can take substrate one material, filler material is another material. All materials are available in that Sinufact welding. No need to bother. So whatever the welding, whatever the materials we are using in the welding, all the things are available in that one. You can select suitable one, and even the trajectory of metal deposition and its length are very simple. This one we have manual. So this is the trajectory you can select. So this one is divide the number of elements by selecting the elements along its path. We can define the trajectory. It doesn't matter. And welding parameters, current, torch angle, wire feed speed, those things can be defined as per our design of experiment. Voltage, we kept 20 volts for all the experiments. If you want, you can change. That facility is also available in the experimentation as well as the software. Gas flow rate, here we have taken 25 liters per minute. And whatever the glass, as per our application, you can change the gas flow rate and types of gases. Those things can also be selected from that one. And as far experiments we conducted. So where we carried out the simulation efficiency at point. Generally, people are keeping the efficiency of welding at 85%. So some people took this one as 0.7 to 0.85 people are selecting. So you can take whatever between these two ranges, no problem. So most of the cases we have seen 0.85. That's why we took the 0.85 as suggested by that one. This one, the heat source is defined by the double ellipse model to simulate this one, where the ABCD values you have to define as per the design of experiments based on the current and other parameters. You have to select these values for that heat source model for that one value of AF, that is front, rear length, width and depth of this is weld pool can be defined. That is based on the process parameters. You can define these values and put that one. And after that, if you run the simulation, see this one. After running the simulation, you will get the simulated weld bed. This is in the second figure. First figure is experimented weld bed. Second figure is compared, that is simulated weld bed is compared with the simulated weld bed is compared with the experimental weld bed. So the two figures were joined there. We say width, depth and the height of weld bed are same as the experimental weld bed. So where there is error we have, that is less than 5%, it is not considerable amount. So that is, see this one where we compare that experimental results, simulation results almost same, almost in the second figure we can say almost same as the experimental weld bed. So in this present study, what we did, effect of arc force, not only arc force, and effect of, see this one, in this experiment, we conducted 16 experiments taking the 4 input parameters. Current is 1 input parameter, 150, 170, 190, 210. Torch angle we took only 2 levels, 60 and 90. This is welding speed 5, 6, 7, 8. So 4 welding speeds, and this one is VS is the wire feed speed. Sorry, VW is the wire feed speed. Third one is wire feed speed 5, 6, 7. This is VS is the welding speed 0.2, 0.3, 0.4, 0.5 meters per minute. So during that during this welding process, after performing this experiment, the workpiece was taken out. As for this is, see this one. See this one, the weld beds formed on the plate. We cut this plate across this one Generally we followed the wire EDM. Using that wire EDM technique, we cut that one. Under the microscope, we measured the width of weld bed. See this one, depth of weld bed, width of weld bed, height of weld bed. These three were measured. See this one, these are the weld bed under the microscope for the first 4 experiments. So like that we measured the 3. This is PC. This is power consumption we measured while the experiment is going on for the 16 experiments. And this one is the total cutting force. F is the total cutting force estimated using the equation 5. Using the equation 5, we estimated the arc force. So arc force is estimated using that one. This one is measured. We cannot measure this one, width of weld pool. See this one. See this in this figure. Yellow region represents the width of weld pool. Yellow region. So yellow region is the width of weld pool. So we cannot, because that melting is done, even we cannot see that one. With the help of mask, we are able to see the arc during the welding process or this metal additive manufacturing. So some of the researchers used high-speed video cameras to capture the width of weld bed. So cost of that one, cost of the high-speed video camera that is equipped with microscope, cost of that one is more than 15 lakhs due to limitations in that equipment which is not available to us. In this present study, what we did, this was that width of weld bed is predicted. This width of weld bed is predicted by the sinew fact welding. So before doing that one, we have some research evidence. Some researchers did the experiments and measured the width of weld pool using the scholars. There is another work which is under review at high impact factor journals where weld bed predicted weld bed, that one also we did that work. I don't want to disclose that work. Okay. So here we used it. I used the SimuFact welding software. I simulated this welding and where I measured the width of weld pool. So to confirm this one, the experiments which are conducted by other researchers using the that is high-speed video camera at that working conditions, we performed this simulation and compared that one. After confirming the accuracy of this software, then only we took the software here to predict the width of weld pool. Okay, we found the width of weld pool. This is the experimental setup. So robot is cost around 38 lakhs. We purchased using this one. We carried out experiment as per design of experiment, that is orthogonal array of L16, and for in the each experiment we have measured, that is depth of weld bed, width of weld bed, height of weld bed, width of weld pool, power consumption, and arc force. So here our aim is that width of weld pool is to be reduced. See this one, width of weld pool is to be reduced according to our requirements. Width of the weld pool is to be reduced. If you are able to reduce the width of weld pool, definitely width of weld bed is also reduced, and ultimately we want to increase the height of the weld bed. So it is our requirement. So height of this, that's why you have to maximize the height of the weld bed, minimize the width of the weld bed, and minimize the power consumption also. Our target is optimization of weld bed as well as optimization of power consumption. What do you meant by the optimization of power consumption? That we want to reduce. What do you meant by the optimization of weld bed means? So we want to increase the height of the weld bed, reduce the width of weld bed. That is our aim. So depth of the weld bed plays very less role. So now that is our aim. Now here effect of the arc force. Effect of the arc force at 60 degrees. See this one. So see this arc is that is welding torch is kept at 60 degrees here. Welding torch is kept at 90 degrees. At see this design of experiments conducted at 60 degrees and 90 degrees. And the effect of arc force. See this one, effect of arc force. See in the second figure, the total arc force is applied on the weld pool. That's why depth of weld bed is more. Depth of the weld bed is more. Actually, we don't want that much of depth. If the depth of weld bed is more, height of the weld bed is decreased. So not only that one, width of the weld bed is also increased. When the arc force is more, when the arc force is more, what happens? Depth will be increased, width also increased, and the height will be minimized. Depth increased, width increased, but height of the weld bed is reduced. So that is why it is not required. So at 90 degrees it was happened. So depth, width increased. When these two are increased, height of the weld bed is reduced. That is not required. See in that first figure, if you see, where the arc force, this one is arc force is applied on that one. So the arc force is resolved into FHA and FVA. A means position A. So horizontal component, no effect of horizontal component on the weld bed. So here we have the effect of, see this one, amount of this that is vertical component at the first figure is less on that one. So these details, the effect of arc force at 60 degrees, 90 degrees is studied here. See this one. In each experiment, this experiment 1 or 2 conducted at 60, 3 and 4 at 90 degrees. So like that, at what position the experiment was conducted, arch angle and experiment number is also given here. When the, see this one, that depth. So when the depth of arc force is more, so this when the arc force is more, depth of the weld bed is also more. That is what we are seeing from 1 to 15. You may get out that at 15, 16 also you have the 60 degrees, but current is more. That the arc force is directly affected by the current. So effect of current on the arc force is more. In the experimental, see this one, design of experiments, we are increasing the amount of current. So here also in this figure, irrespective of the torch angle, this is getting increased as the current is increased. But we are seeing the difference between at 60 that is less. At 90, arc force is more. At the same time, depth of weld bed is also found more when the arc force is increased. So that is the effect of arc force on the depth of weld bed. When the depth of weld bed is more, definitely width will be more and the height is reduced. That is not our requirement. When you are able to reduce the arc force, then the depth will be reduced, width is also reduced, height of the weld bed is increased. That is our aim. So that we are seeing now. So this in this slide you see the how that correlation among the width of weld bed, height of weld bed, width of weld pool. So how the width of weld pool, see green line is the width of weld pool. When it is increased, that width of bed is increased. See this one, we can see the correlation among the 3 output characteristics. So now using the TLBO technique, we want to see this one, maximize the height of weld bed, minimize the width of weld pool. If you are able to minimize the width of weld pool, so we can minimize the depth of the weld bed, and we want to minimize the power consumption. Seeing this optimization, let us see the what is the TLBO technique. This is teaching learning based optimization technique. Generally, we used to follow in classroom. For suppose in the classroom there are 30 students, we newly entered the class to handle one subject. So after 1.5 unit or 2 units, we conduct mid exam. After mid one exam, we get the mid marks. Based on the mid marks, okay, we analyze the students' performance. So, for suppose if the mid is conducted for the 30 marks, the students who got more than 20 marks, we call them as bright students. Okay, let us keep that is 25 marks. The students who got about 25, we call them as better performer. The students who got marks less than 15 marks, he failed, they are called as poor students. Who got marks 15, that is 15 to 25, got the moderate students, medium students. So generally what the teacher, if the students who got less than 15 marks, definitely most of them going to fail in that subject. What the teacher will do, generally he will take slow learner classes, extra classes to them. So intelligent staff, what they will do, they pair the student. They identify one bright student, one slow learner. Bright student and slow learner, what he's doing is pairing them. That is called as mentorship. One poor student, one bright, that is bright student, when they are paired, knowledge is transferred from bright student to poor learner, and after for the second bit, if you say, performance of the slow learner will be increased at the end exam also, all the students will be passed and will get the appreciation. The teacher will get the appreciation. So that is about it. Generally we follow. So first what we are doing, first we are delivering the knowledge to all the students. After that we find the bright student and slow learner. We are pairing them to transfer the knowledge from bright student to slow student to improve the overall performance of the class, and finally teacher performance. Same thing in the TL view also, teaching learning based optimized technique also, same thing is followed. That number of experiments, see this one. Here we have in this one, these 16 students here we have, 16 students. Now these output characteristics are subjects. Output characteristics are subjects. So like that, initial population is same. First the teacher will deliver the lecture. That knowledge is transferred from bright student to slow student. How it is happening? Let us see now. See, first we have to define the criteria. What are the criteria? So, for suppose in that particular mid to, all the students should get more than 20 marks for the subject. If the subject is stuff like applied thermodynamics, okay, more than 20, that the student who got 8 marks, he cannot get more than 20. For him, we said the target is about 15 to 16 marks. So like that, that the constraint is varying from one subject to another subject. Like that, here also we take the constraints. So first of all, see, we have total 5 subjects. See this one, 1, 2, 3, 4, 5, 6. Here we have the 6 subjects. In that 6 subjects, see, here we have taken only that already that art course, the effect of the art course on the development we already studied. So here we have taken 5 subjects only we have taken here. So we generated the linear equations for the height of weld bed, width of weld pool, and width of weld pool, power consumption, depth of weld bed, width of weld bed. These equations generated from the experimental data. Simply you take the experimental data, put in the mini tab where you have the regression analysis. Using that regression analysis, we can generate these equations. And the R square value is above 0.9, then only you have to take the linear equations. All these equations were taken. Our aim is to maximize the height of weld bed, minimize the width of weld bed, and minimize the power consumption. Here, see this one, depth of weld bed, width of weld pool, we cannot minimize, but which are restricted to, see this one, which are restricted to. Depth of weld bed should not be more than 1.5. Always depth of weld bed should be less than 1.5. Width of weld bed always should be less than 7 mm. So like that we have the constraints. By keeping these constraints in view, we have to optimize the process parameters. So All these 5 equations are generated using the experimental data. So here, height of well bed is able to maximize while minimizing the width of well pool and power consumption. Keeping these two as constraints, depth of well bed is should be less than 1.5 mm. Width of well bed should be less than 7 mm. So based on the capacity of the robot and previous research works, these parameters are bound. So the current should be within these two limits only. This should be 120, should not be more than 300. Based on the previous experimental work, I already explained. So in the previous work, one second. See this one. This person found that pool stability was improved by keeping the touch angle smaller than 90 degrees. So like that, we conducted the experiment between 60 and 90 only. So that is, and also here the constraint of that input, see touch angle. So between these two limits, similarly wire speed between 2 to 10 meters per minute, welding speed is between 1 to 1 meters per minute. These input parameters should not cross these two limits. So what is meant by this one? Okay, in details we will see later. Next one. So before seeing this teacher phase, this phase again I will come back to the equation 12, 3, 14. See this one. Same. This is the initial population up to here width of well bed. Same table was taken from the experimental data. See this one. We have the two constraints. This is Z depth of well bed, Z width of well bed. Z dash is the overall constraint. Very simple. Don't feel confusion. Simply I will tell. You see here how to find out the constraint first. Generally here we have taken two constraints. That finding the constraints for the depth of well bed, width of well bed, we see here. So constraint of well bed. So depth of well bed minus 1.5. For the width of well bed minus 7 based on these constraints. See this one. Depth of well bed always should be less than 1.5. Width of well bed should always be less than 7 mm. So depth should be 1.5 mm less than that one. Width should be less than 7 mm. See, you come here. Now if you come this one, constraint for depth of well bed. See this one where the value is 1.182. 1.182 minus 1.5. 1.18 for the experiment 1.182 minus 1.5. So where we will get negative value? Negative values are to be taken as 0. Positive values are to be taken as it is. See this one? For the experiment 4, 1.391 minus 1.5, you get the negative value we have taken is 0. So see this one 1.739 minus 1.5, we can get 0.239. Like that we have taken all the negative values as 0, positive values were taken as 0. Similarly for this one also. For the experiment 1, see this one, width of experimental value of width of element minus 7. Same thing. We have taken this one is 8.967 minus 7, where you got the 1.967. Similarly for this one also. For third one, if you see 6.741 minus 7, where you got the negative value. Negative value was taken as 0. So here also you have the negative value less than 7. You have taken 0. So this one is less than 7. Negative value you took 0. So whatever the values you got negative were taken as 0. Positive values were fine as it is. Next one, if you see, this is the overall constraint. How to find out the overall constraint? See this one. Z is the overall, Z dash is the overall constraint. So ZDW. So for the experiment 1, constraints of depth of well bed by maximum value. See this one, this is the constraint of width of well bed by maximum. What is this one here also? Don't confuse. See, among all these things, you take the maximum value. 0.992 is the maximum value for that one. That's why you see this one 0.992. See this one, among all these things, this is 2.599 is the maximum value. That values were taken here as the Z depth maximum, Z width of element maximum. So using this one, see this one, Z this value. See this one, 0 by this maximum value plus this one by max value, you get this value. Overall constraint for the exponent one. Similarly, overall constraint was estimated using the equations 13, that is 12 to 14. Overall constraint is estimated for the 16 experiments based on the constraint. They should be 0 because here we have taken minimization problem. So you see this one, these things should be less than this one. That's why the constraint value which are having low values are given better ranks. After the remaining things will be given the remaining ranks. So like that we have all the ranks, all the experiments are ranks assigned. So next one, this is called as first step in the teacher phase. So each phase is having 2 steps only. You need not to confuse. Only 4 steps. In 4 steps, we can conclude that work within 10 minutes. I will complete. I think I have only 10 minutes of time, 12 minutes of time. I will try to complete. I will complete. See this one. This is the first step in the teacher phase. So knowledge is transferred from teacher to student. So first mid was done. First mid was done, and he gave the ranking. Now, how he analyzed it? So what he did, before pairing, he took some concentration on that one. Just like slow learner classes, he carried out. So after slow learner classes conducted to the students, again he will evaluate the performance of that one. How he conducted the slow learner or extra classes, how it was happened, let us see now. So as per TLBO technique, we have to find out the average values for the 4 input values. 180 is the average for this one, 75 for the touch angle. This is wire feed speed, 6.5, 0.35 is the average value. So average value are taken. Using this average values, difference underscore mean. Don't bother of these words. All these things are arithmetic. Don't worry of that one. This simple calculation we are using subtraction and addition. That's all, not more than that one. You listen, just you listen, I will explain you. So here you have to find out the difference underscore mean. So for the current, touch angle, wire feed and welding speed. How to find this? Here we have equation number 15. So that is P is the random number. Don't bother of the random number. Random numbers. That is 0 to 1, whatever the value you wish, you take that one. Q is the process parameter, Q dash is the mean of the process parameter. See this one, Q is this one 150 minus mean value 180. So P is the random number, whatever take. See this P is value, it is to be taken 0 to 1 between the range. So Q is the process parameter, that is 150 minus mean value 150. How the calculation, sample calculation is given here, is see here. So for the current, we have taken the random value 0.9. Say 180 minus 150. That is what is said here. Process parameter minus mean value. Same thing. 150 minus 180 was taken here. This too. P is the random number. I have taken here that random number is 0.9. Whatever you like, you take whatever the value. So in the reverse order also you can take, it doesn't matter. For the touch angle, so 90 minus, see this one, 60 minus 75. So like that, okay. This is 60 minus 95. Oh, the reverse order it came, no problem. So similarly for this one also, okay, some typing mistakes were done. Okay, I will rectify. 150 minus 180, 60 minus 75, 5 minus 6.5, 0.2 minus 0.35, like that were taken here. So these are the random numbers. So we will get the values. These values, see this one, difference underscore mean values are added to these inputs. So difference underscore mean value is found for the current TA and wire, and this one is welding speed. Third VW is the wire feed speed. See that different underscore mean values are added to the input parameters, and we got the new process parameters. These are the new process parameters. So after getting the new process parameters, however, you have the equations. See this one, 7, 8, 9, 10, 11. In these equations, we have the Excel will get the height of weld bed, width of weld pool, power consumption, depth of weld pool, and this one is width of weld bed. And similar to this table, constraints are assigned. See, this constraints are estimated and the ranks are also assigned. So still, that is even slow learning also. Even in the slow learning classes or extra classes, the class performance is not improved up to mark. Then what the teacher will do, these two, table 3 and table 4, sorry, table 3 and table 2, these are combined. So that is called as combined phase. Don't worry. The 16 and these 16s were combined. Among the two, 32 experiments, we selected 16 best experiments from the two, table 2, table 3. Those, that is the two stages we have in the teacher phase. In the two tables were combined. Best 16 experiments were shortlisted. Those are presented in the table 4. This is the end of the teacher phase, called as combined population, or the output of the teacher phase. So he tried through the slow learning and the extra classes, but the class performance was not in only very less number of students' performance was improved. That is why what he's doing, he identified the best students and slow learners and paid them. So how he paid, that we see here. So he allowed the interaction between 116, 215, 314. See this one. Interaction is carried out between best students and the slow learner. So here randomly, one student, experiment 1 can be interacted with the remaining 16, remaining 15. It doesn't matter. Even you can take the 7. This is interacted with the these one also. So whatever the way. So here also, the interaction can be performed randomly. Whatever the way you like, you can follow. So one systematic way I followed in the study, interaction between 116, 215, 314, 413, like that interaction is performed. So that how the interaction is performed, see this one. So here also, this is new current, new torch angle, new wire. This is wire feed speed. This is welding speed, A1, A2, A3, A4. Again, we took the random numbers. You can take the whatever the values you like. And this one is current 1, current 16. This one, see this one, current 1, 150 minus 150 minus 190. You will get minus value.
Professor Venkatrao, sir, sorry to interrupt you. Sir, still how much time it takes, sir?
Only 10 minutes.
Okay, sir.
I'm going to finish.
Okay, thank you.
Class that?
Okay. We have a plan of again valedictory function also.
Okay. I will close it. Okay. This is somewhat complex, that's why.
Okay.
Right. See, use through the sequence 16, 17, 18, 19, new process parameters are obtained for the 16 experiments. So these are the new. See, somewhere we are seeing star marks 90, 90. Say I told you, see this here 120 star mark like that. Say always the current should be less than 120, and this torch angle also we gave the bound values, parameter bound values. If the values cross this one, that bound values only to be taken. That's why star marks represent the bound values. When they cross that limit, that upper value or lower value will be taken. So here we got the new process parameters using the equations that already I told that again new responses were found, again ranks were assigned. So this one is the teacher phase, and again this teacher phase, this one interaction phase. See this one, new process parameters were found using that equation, responses were found, these constraints were also found, and here we got the 7 best ranked students in the interaction phase. So before this one, table 4 you have the 7 best rank, and after interaction also you have 7 best rank. These 7 plus 7, 14 best solutions we got. So based on the ranks, so 14 best solution we found here. How to find out the best among these 14? You can take either one. Among these 14 also you can find the best one using this. This crowding distance was found, equations were here. So these are available with the Raipur Venkatrao papers. I also published 3 papers. This is one of my papers. 2019, power consumption of strategy in ball, micro ball and milling outputs, TLP coupled with 3D from simulation. It was published in measurement. So there also these equations are available. So using these equations, 21 and 22 crowding distance were found. So finally we find the experiment 13 and 14. Experiment 13 and 14 were found as optimum working conditions, where you see the depth of weld bed. We gave the constraint should be less than 1.5. Width of weld bed, we gave constraint less than 7 mm. So in these 2 experiments, we got the depth of weld bed less than 1.5, width of weld bed less than this one. As per our requirements, as per our constraints, we got this one, and the height of weld bed was included in these 2 cases. But the power consumption variation we have, but between the 13 and 14. Based on the power consumption, experiment 13 is having less power consumption when compared with this one. That's why 13 was taken as the optimum working condition. Thank you very much. If you have any doubts, you can ask me now.
Sir, Professor Venkatrao garu, is that okay? Can we move on to question and answer sessions?
Yeah.
Okay. Now I request Dr. Shobha Madam, please can you go through the question and answer chart box? Can you read out the questions raised by the participants?
Yes, sir. Sir, Satish Kumar sir was asking regarding the quality issues that to be taken care in additive manufacturing, and due to which there may be a possibility of void formation in the final tool. Sir, shall I repeat the question again?
Yeah.
Sir, quality issues to be taken care in AM.
No. In AM quality, you are asking about the quality.
Yes, sir.
Yeah. However, before conducting experiment based on the previous data available, we have to ask. Before that one, you can do one thing. As for slow, that is low levels of design of experiment, first you have to conduct the experiments. Based on the experiment, that each experiment will be repeatedly conducted until we get the average value is to be taken. For that average values of width of weld bed, depth and height, taking those things in consideration.
Sir, Sandeep, Dr. Sandeep is there?
Yes, sir.
Can you is my screen visible? Sir, Dr. Professor Venkatrao, can you stop your screen share?
Okay. I stopped the screen share.
Okay, sir. Okay. I asked my Dr. Sandeep, could you please confirm whether the screen is?
It is being shared, sir.
Yes, sir.
Not at. Yeah, now it is shared. I think. Your
Shared,
photo
sir.
is coming. Yeah.
For me, dark is coming.
No. Screen is not visible.
That is why, sir. Okay, sir. Due to some technical issues, now I request Dr. Padmini Madam to summarize the session. Actually,
yes, sir, sure.
Madam, can you, because your voice is clear, can you read out some questions which are in the Q&A?
Yes, sir.
Thank you,
sir.
Dr.
I didn't
Shobha
get
Madam.
you, sir.
Shobha Madam, thank you. Due to some technical issues, your voice is not clear.
Okay, sir. Okay.
Sir, am I supposed to give the concluding remarks now as per the schedule?
Try to share the question and answers from your screen, chat box.
No, sir. Presently, I'm not having that pop-up here.
We have okay. I opened that question and answers. I have only one problem. That one also I answered. Okay.
Sir, Dr. Venkatrao, please go through the comment by.
Only one comment I have. Remaining things are very good approach like that. I would like to.
Pujita Rama, one of the participants, she gave some comment.
I would like to understand the difference between powder additive and this one solid. So actually powder additive manufacturing is the best one, where you will get a good mechanical properties. No doubt of that one. Powder is best. Okay, that was also answered. Whether the output changes depends on, okay, we asked that Harshini, whether the output changes depends on the selection of random numbers or not. It is not like that. The random numbers will not affect. If the you can repeatedly, I explained only one constraint. At one constraint, I got our required outcomes. If you are not able to get the required outcomes, these iterations to be repeated. So that Raipur Venkatra, he provided the MATLAB code in the online. So you can download it, you can follow it from the number of iterations you can perform until you get the required your outcomes. Over. Okay, it's over. So, sorry, another Suresh asked another question. Any institute is there to conduct research work? Okay, they can come to our university. If the university have the equipment, they can come and carry out through proper channel. Okay, we will also help you.
Okay,
so
sir.
All questions were solved.
Okay, Dr. Professor Venkatrao Garu, thank you. Now I would like to request Dr. Padmini Madam to summarize the session.
Sure, sir. Good afternoon, dear panel members, dear delegates, and all the attendees. I think you had good sessions yesterday as well as today. And now I take this opportunity to thank Professor Venkatrao, sir, for having launched us on a knowledgeable journey through the applications of teaching learning based optimization technique in metal additive manufacturing with a detailed case study approach. Sir has focused in detail on stability of thin wall parts in robotic GMA based additive manufacturing, followed by finite element modeling of weld pool with experimental simulations. And Sir has discussed also all the parameters with constraints and all the inherent values which have been considered during the experiments, all the positive as well as negative values and why the values have been chosen. These details hardly are discussed in any talk. We must thank Sir for having disclosing all these details in fact. One interesting part is the analogy. One interesting part was the analogy between the use of teaching learning based optimization technique and how we use that in teaching and how it has been applied in metal additive manufacturing. Sir has really discussed wonderfully. I thank on this eve or note, thank you very much, sir, for your multi-dimensional explanation on the content. Thank you very much, sir. Over to BSP, sir.
Okay, madam. Thank you, Padmini madam. Now, I would like to request Professor H. Ravishankar of Mechanical Engineering Department join us as a chief guest for the valedictory function. Professor Ravishankar sir, please join, sir.
Yeah. So can I?
Yes, sir. Now I'd like to request Professor Venkatrao from Vigyan University as a guest of honor for this valedictory function. Please join, sir, Professor Venkatrao.
Yeah.
Thank you.
Sir, on this occasion, as a convener for this particular today event, I would like to present because there are so much of feedbacks we have received from the chat box, sir. And I have not, based on their request, we have selected a few participants from various places. Now I would like to request Professor Radhakrishna Pradeep Kumar, sir, to present his feedback. Sir, can you hear me, sir?
Yeah, I can hear you, but
Yes,
am I audible?
Yes, sir, audible, sir. Please go ahead, sir.
Okay, so first of all, my heartfelt congratulations to all the organizers for selecting topics that has fostered collaboration amongst scientific interdisciplinary domains. And I'm sure GITAM would set standards in this method globally. And all of us has to embody the spirit of combining disciplines. And GITAM, with all the specialities and so much of resources in its campus, I'm sure can take a lead role globally in fostering this interdisciplinary collaboration. And it's not only that, you have actually brought a direct focus on practicing and developing these skills by the interdisciplinary group. Medicine, especially after technology has invaded it, we have a lot of technical challenges, especially mechanical engineers, electrical engineers, and all these people can help us to overcome these challenges and give individualized patient care. That is where, I think universities like GITAM can be a role model for the whole world. And I should thank the mechanical engineering team, for having inspired me to take up so much of challenging projects after I have reached GITAM, and hopefully in a few years' time, I know we can take the leader's role and other universities can follow. Thank you so much.
Thank you, sir. Sir represents the medical stream. He is a professor at surgery at GITAM Medical College. Thank you, sir, for giving your valuable suggestions and for improvement. Thank you very much, sir. Now I would like to request a scientist from Netherlands. He studied at Delft University. He's a senior scientist at CITC organization. Now I request Dr. John, please give your feedback from Netherlands.
Thank you, Dr. Prasad. Can you hear me?
Yes, sir. Please go ahead, sir.
Yeah. Thank you very much. I am really excited listening to this whole story. As you, when I look back from yesterday, I have been following the all the details, and I'm really impressed in the sense that you started the whole story with a necessity because of this Corona crisis. We have a necessity, and I feel that necessity is sort of mother of inventions for everything. For myself, I feel that Europe, because I'm in Europe, I see that Europe has developed because of the necessity, because they had to fight against the weather. And I see that Corona has sort of gave us all the necessity to come with an idea, and then you came up with this nice idea of why not starting a conference which is related to exciting advances in manufacturing. And of course, this is like a seed which you got an idea, and then that idea got in the soil, which is like GITAM University, and you took that opportunity, and then it was well groomed by the whole staff, and then it became a conference. I'm really excited to hear this whole technical presentations, especially starting from Dr. Naveen Garu. He started with the submicron level scale, which is from the natural beings, like from spiders, which is, I see that his presentation was, when I look at it, the spider is absolutely like a nice 3D printer. It was printing so precisely, and it was fun to see it. And then you talked about bees and mosquitoes and dragonfly. Actually, we were doing in Delft University part of this research on dragonfly. That was 10 years back. Now I'm not into academics in between. I'm into semiconductor business. So, but because of that, I understand a lot of things like on the 3D printing, and especially today's morning presentation about reliability. That was one of the real challenges for launching any product. You need to be able to predict the failures beforehand, and also you need to estimate the lifetime. So it is a very new touch with reliability and adding artificial intelligence into it, which is really it's a new latest researches which are going on. And finally, I heard Professor Venkat Rao. He was into additive manufacture, which is I think he is technically into very detailed things. But he touched both all the three concepts of additive manufacturing via FEM with the latest artificial intelligence. So for me, I'm for my takeaway is that this whole thing has inspired everyone, and I think I take this inspiration as a need for everyone from different communities, not only mechanical, but from, as we see, from biomechanical or dental or other streams, to be united at this particular time of Corona, where our when nature throws challenges to us as engineers and scientists, we need to get united and come up with innovative solutions at this time. I thank you for this opportunity.
Thank you, Dr. Suman. Thank you, Dr. Suman from Netherlands, CITI organization. He's a senior scientist. Thank you. Now, we would like to hear the feedback from a faculty of a reputed engineering college in Visakhapatnam. I invite Dr. Amrita Madam to present her feedback. She is Associate Professor at GIT College of Engineering. Over to Amrita Madam.
Good afternoon, one and all. First of all, I'd like to congratulate Department of Mechanical Engineering, GITAM University, and especially all the organizing members for starting a seminar series on exciting advances in manufacturing automation 2020. Really, all the sessions were really exciting and we could learn a lot. All the 4 talks organized were apt for the topic of the seminar. Works discussed by all the 4 resource persons, Dr. Naveen Kumar sir, Dr. Arvind sir, Dr. Faiz bin Mohammad Turan sir, and Dr. R. Venkat Rao sir. All of them covered recent advances in 4 different dimensions in our mechanical engineering, that is in materials, engineering application to medical sciences, industrial engineering and manufacturing. Sir, all the sessions were very informative, and I personally could gain a good knowledge on the research works going on in all these 4 areas. Thank you so much for giving me the opportunity to share my thoughts. Thank you, sir.
Thank you, Amrita Madam. A feedback like this from a good researcher like you is always inspiring. Thank you. Now I would like to request, because as part of this particular conference, specifically nearly 40 to 50%, 50 members have joined only on a particular session, that is on dental session. One doctor has requested to present his feedback. Now I'd like to request Dr. Shaheen to present his feedback. Sir, please, over to you, sir.
Very good afternoon, everyone. Am I audible, sir?
Yes, sir, audible, sir. Please go ahead, sir.
Okay.
Firstly, Dr. Shamin.
Yeah. Thank you for addressing me,
Yes,
Dr. DSP, sir.
Yes.
Firstly, I'd like to thank M. Sachinarayan, sir, Professor, Head of the Department Mechanical Engineering, GIT, and the entire team, sir, for successfully conducting a wonderful webinar series. I attended the session on 3D printing and its applications in dentistry and OMFS by Dr. Aravind. Indeed, it was a wonderful session where Dr. Aravind has provided a deep insight pertaining to the 3D printing topic. And of course, he also shared his valuable experience in the same field. So I really appreciate his efforts and thank him for the wonderful session. I also would like to thank Naveen sir, Faiz bin Mohammed Tarun sir, Venkatrao sir, for being a part of this. Coming to my experience with the Department of Mechanical Engineering, many of our students do visit your department, for guidance regarding testing of various dental materials.
Yes,
As a part of
Dr. Shamir, the in charge is also coordinator for this, Dr. Sandeep.
Yeah. Yes, sir. So I'd like to thank Dr. Sandeep and the entire department for your valuable guidance, to all our PG students. So I extend, my thanks to the entire department, and I also hope you would continue your support in the same manner that you've been doing. Finally, I'd like to convey my special thanks to you, sir, B. Srinivas Prasad, sir. Without you, I wouldn't have been part of this program. Seriously, I'd like to thank from the bottom of my heart. And I hope the department will continue the same similar webinar series for the benefit of the students, the faculty, as well as, every needy. Thank you very much, BSP sir, and the entire team once again. Thank you.
Okay, sir. Thank you, sir. Now, so far we took the feedback from the dental practicing doctor and a feedback from an abroad. Now I would like to invite a student representative who is a full-time research associate at the Department of Mechanical Engineering. Now I would like to request him, Azam Nawaz, to present his feedback.
Hello, sir. Very good afternoon, sir. Thank you for giving me an opportunity to give a feedback on the session. So very good afternoon to all the professors and attendees of the today workshop on exciting advancements in manufacturing and automations, which was conducted by all the GITAM mechanical department team members. It's a very pleasure to have this workshop session. We could able to get more knowledge even being at home during this pandemic session. I'm a research fellowship in GITAM University under the guidance of Shobha Madam. And I've been also a student for the Balla Srinivas Prasad sir in the past, master student. He guided me everything in every aspect, and not only him, every faculty in the GITAM University in mechanical department were very much collaborative, and they are very much informative in providing all the solutions or to the students who are looking for problems, who are facing some problems in their research work and all. So during, I felt very glad to attend this session, today's session, and I learned a lot from Professor Aravind sir on 3D printing, which has enlightened me a lot. And also this thank you very much, sir, Balla Srinivas Prasad sir, for taking the GITAM University to global level, inviting Doctorate Faisal Turan sir from University of Malaysia, Pahang. And lastly, a very good informative session on the SimuFact software and finite element software on the finite element simulation of weld pull and the techniques involved in by Dr. K. Venkatrao sir. It is very pleasure, sir, to listen to the session, and it's very clean explanation given by you, and also the optimization techniques. I'm very thankful to all my faculty from GITAM, and all on behalf of all the attendees of the workshop. I am very much happy to attend this session, and I would like to have sir. I would like to ask Balla Srinivas sir to continue this progress and organizing more hands-on virtual training programs, as well as also a theoretical programs like this, which will give a student more exposure to the industrial representative research scenarios. Very much thank you, sir. Very much thank you for all the panelists and all the attendees who have shared the valuable feedbacks about the GITAM Mechanical Department of Engineering. Thank you, sir.
Thank you. Thank you. Dr. Sandeep is with us. Are you there, Dr. Sandeep?
Sir, I'm there with you, sir.
Okay. Sir, before before concluding them, submitting the concluding remarks by our chief guest, Dr. Ravishankar Garu. Now I would like to request Dr. Venkata Garu to present his reflection. Dr. Sandeep, be ready with the vote of thanks. Venkatrao sir, unmute yourself. Okay, sir. Please proceed, sir.
Okay, thank you, B.S. Prasad, Dr. B.S. Prasad. I would like to thank to the Department of Mechanical Engineering, GITAM University, and organizers, B.S. Prasad and HOD. I congratulate you. It is one of the opportunities to me to explore my research work to the research community. I think they benefited from these 4 sessions. Not only listening this kind of programs, they should find the problems to carry out their research work. I think it is fruitful to them. They will find the problems to carry out their research work in new areas. Thank you. I wish you all the best for the participants. Thank you.
Thank you, sir. Thank you, Professor Venkatrao. Now I would like to request Professor Ravishankar Garu, Mechanical Engineering Department, to present his concluding remarks from the department.
Yeah, thank you, BSP Garu.
Yes, sir. Thank you, sir.
First of all, I congratulate all the participants for their participation in exciting program.
Yes, sir. Yes, sir.
Exciting Advances in Manufacturing Automation 2020. Really, by the name, it is really exciting. And all the 4 speakers, Naveen Kumar, Aravind, Faz, and Mr. Venkatrao Garu, Dr. Venkatrao Garu, has given a wonderful lectures, and it is very informative and exciting. So I request all the participants to carry forward the knowledge what you have gained, all the sessions. Please do your research in the respective areas. And if any help, our faculty of mechanical engineering is there, who are working in these areas. You can approach them. You can carry forward this research. And I congratulate, being a mechanical engineering professor, I congratulate Professor M.R.S. Garu and Dean Engineering and Principal for their kind support in organizing this exciting event.
Yes, sir.
Thank you, sir. Thank you, BSP.
Yes, sir. Thank you, sir. Before Dr. Sandeep is going to submit the vote of thanks, I would like to mention as a convener few names. Sandeep, are you ready, sir?
Yes, sir. Yes, sir.
Okay, sir. So as a convener of this particular program, I want to mention a particular name. He's a scholar under my guidance, Mr. Chandramouli. He worked along with me day and night. On this occasion, I would like to say he's my student. I don't want to say much beyond this. Thank you, Chandramouli, for assisting me. If this is successful, his hand is behind that. Now, one more thing. Myself and Sandeep have started this particular event, but we received a very good hand from Dr. Padmini and Dr. K. Suresh. He is also worked equal to us. Thank you, Dr. Padmini and Dr. Suresh, for assisting us whenever we are thinking about some helping hand is required. You both are always ready.
Thank you, sir. It's our responsibility. Thank you very much.
Thank you. This sort of team spirit is required to extend further to the next level. As it is named as a series, definitely we would like to continue this particular series. And now the participants. Dear participants, GITAM is appreciating your participation immensely. You are going to receive this feedback form on your email. If any issue regarding your certificate FAK, please mail to me, or you can contact me over 9848-3210-321070 or sbala@gitam.india. Now, at the outset, I would like to thank personally for all the experts who accepted my invitation to be part of this particular 2-day event. Thank you very much, sir, including Dr. Venkatrao. And he is the person who inspired me to organize this. Thank you. Over to Dr. Sandeep.
Good afternoon, sir. Sir, can you able to hear my voice?
Yes, yes, please go ahead.
So on behalf of Department of Mechanical Engineering, I deemed it's a great honor and privilege to propose vote of thanks for the 2 days global virtual seminar series on exciting advances in manufacturing automation 2020. Firstly, I would like to thank our speakers, Dr. Naveen Kumar Garu, Dr. Arvind Garu, Dr. Faiz Mohammad bin Turan Garu, and Professor K. Venkatrao Garu for accepting our invitation and attending this occasion to deliver a valuable lecture. In spite of your busy schedule, thank you, sir, for supporting us all through the endeavor. Thank you, sir. I would like to take this opportunity to thank our Honorable President Shri Bharat Garu. Under his leadership, we are encouraged in doing these kind of activities, global activities. Thank you, sir, for providing such platform to all the faculty members and students in this pandemic situation. I would like to thank our Honorable Vice Chancellor, Professor K. Shivaram Krishna Garu, for accepting our invitation and attending the occasion. As always, the sir is inspired and encouraged with the valuable words and helping hand. Thank you, sir. I would like to thank our Dean, Professor C.H. Vijay Shekhar, sir, for attending the occasion and instrumenting in doing this virtual seminar series. Thank you, sir. I would like to take this opportunity to thank our esteemed principal, Professor C.H. Dharmaraj Garu, for giving constant support to conduct the global virtual seminar series. Thank you, sir. I would like to thank our head of the department, Professor M.R.S. Sachinanand Garu, for his constant encouragement in organizing this event. Thank you, sir. I would like to thank our Director Research and Consultancy, Professor R. Rajapoppu Garu, for extending the valuable support all through the event. Thank you, sir. I would like to thank our convener, Dr. B. Srinivas Prasad Garu, for coining this 2 days global virtual seminar series for on exciting advances in manufacturing automation 2020 and extending his valuable support all through the event. Thank you, sir. I also thank all the distinguished invitees, Dr. V. Srinivas Garu, Dr. S. Narayan Rao Garu, Dr. Surendra Babu Garu, and Dr. Ravishankar Garu present here and extended your support to us. Thank you, sir. I thank all my colleagues for their overwhelming participation. I would like to thank the organizers of the Department of Mechanical Engineering for giving a constant support all through the event. I thank all the participants for attending this workshop. I finally thank each and everyone for being a part and partial of this workshop and made the event a grand success. Thank you all. Over to
sir. Okay, one last point, sir. Our coordinator, and actually, we would like to thank Dr. Y. Ravishankar, Vice Principal, GITAM Dental College and Hospital, for attending one of the session. He has submitted on our request. He has submitted his concluding remarks on a second session, that is on 3D printing with a dental application. This is what missing, sir. Okay, thank you, Sandeep. Thank you, Dr. Venkatrao Garu, Dr. Ravishankar Garu, for your presence as a chief guest and the guest of honor.
Thank you.
Dear participant, thank you for your support. With your feedback, just now we have listened some feedback from various locations. We assume that this attempt is successful. I hope everyone agrees on this. So I want to hear from the guest of honor and the chief guest.
Excellent, sir. It's excellent.
Thank you, sir.
Very good. Very good. Excellent.
Okay. Thank you all. I'm closing the session. Sandeep, okay?
Yes, sir. Right, sir.
Okay, Shobha madam, thank you for your presence.
Thank you, sir. It's a great session,
Okay,
sir.
madam. Thank you, sir. Padmini madam. Thank you, Suresh. Thank you,
Thank
sir.
Thank you, sir.
Thank you, Dr. Radhakrishna, Pradeep Kumar, sir. Thank you all. Bye, everyone.
Bye, sir. Bye.
Bye.